Houston, Tranquility Base here. The Eagle has landed.
We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
ABC News presents Footsteps on the Moon, the flight of Apollo 11.
Good morning, ladies and gentlemen. I'm Frank Reynolds at ABC Space Headquarters in New York. It is July 16th, 1969, and we are all about to witness the fulfillment of that promise that President Kennedy made at Rice University Stadium in Texas on September 12th, 1962. The moon that still has not set in some parts of our world has only a few more days of what you might call untrammeled history. These three men are about to embark on certainly one of history's most glorious adventures. Commander Neil Armstrong, Lunar Module Pilot Buzz Aldrin, and Command Module Pilot Mike Collins. Armstrong and Collins have already entered their command module, and Buzz Aldrin will be entering to join them in a few moments to begin this epic journey, and we shall all see it. ABC Science Editor Jules Bergman is at the Cape. There has been a minor difficulty developed there at the Cape, and let's get a report from Jules now on just what is being done. Good morning, Jules.
Good morning, Frank. We're at T-minus 2 hours and 28 minutes into the scheduled launch of Apollo 11 at 9:32 a.m. Eastern Daylight Time, and the countdown has been going spectacularly until about 10 minutes ago, just before Neil Armstrong, Mike Collins, and Buzz Aldrin started to get into the cabin of Apollo 11. And then a slight leak developed in a valve system that replenishes the liquid hydrogen for the third stage of the Saturn V, the S4B stage. The valve in question is not on the spacecraft itself, but on GSE, or ground support equipment. It's the same valve, the very same valve, by the way, that leaked back on Apollo 10. Everything else here, Frank, is holding up very well. There's a forecast of clouds at 15,000 feet. As we look back to pad 39, right directly behind our ABC News Space Headquarters here at the Cape, you can see the clouds over the ocean. They haven't yet truly developed over the land area, and if it stays this way, everyone in the country and millions of people gathered around Central Florida will get a spectacular eyewitness view of Apollo 11 and the Saturn V lifting off. As it is now, there's a light layer of cirrus clouds at about 15 to 20,000 feet over the Cape. They could cause some interference with visual viewing, but not with the launch itself. The launch limits have gone down really much, if you will, on this fourth launch, we should say, of the Saturn V, fourth manned launch, fifth unmanned. As of now, the weather is good, the countdown going well, except for this liquid hydrogen leak, which has to be fixed, and there's no reason to think we won't lift off at 9:32 a.m. Eastern Daylight Time, as scheduled. That's the story, Frank.
The astronauts of Apollo 11 awoke early today and began their ritual-like preparations for this blast-off to the moon. One of their doctors, as I told you earlier, said they appear rested, fit as a fiddle, and ready to go. They actually had about 8 hours of sound sleep, which is probably more than a good many other people who were preparing for this launch today. They had a big breakfast of scrambled eggs, steak, toast, coffee, and orange juice. And for a film report on their final meal on Earth before blasting off, here's Jules Bergman at the Cape.
Crew astronauts Armstrong, Aldrin, and Collins were awakened at 4:15 a.m. this morning, just about 3 hours ago, after having gone to bed about 9:20 last night, and immediately after a quick medical, had the traditional astronaut's breakfast of steak and eggs. There's Buzz Aldrin, the lunar module pilot. We saw Mike Collins a moment ago. Spacecraft Commander Neil Armstrong, who'll be 39 on August 5th, just a few days from now, led by security guards, waving a farewell as they get into the transfer van for the 3.5-mile ride to pad 39A. Neil Armstrong leading the way, then Mike Collins and finally Buzz Aldrin.
We're back at ABC Space Headquarters in New York, awaiting the still scheduled launch at 9:32 Eastern Daylight Time this morning of Apollo 11. The commander of the mission is 38-year-old Neil Armstrong, the only civilian among the three-man crew, and, of course, the man scheduled to take the first actual step on the moon. The pilot of the lunar landing module is Edwin Aldrin, Jr., 39 years old, and an Air Force colonel. 38-year-old Michael Collins, a lieutenant colonel in the Air Force, is the pilot of the command module. It will be his job to circle the moon while Armstrong and Aldrin are down on its surface. Jules, did you have any difficulty getting out to the Cape this morning?
Frank, we had no difficulty, but we practically didn't get to sleep at all last night just to be sure we wouldn't have any difficulty. The shot we're looking at from the helicopter now is over Highway A1A, the main north-south road along the Atlantic, and we're looking at the beach just below the South Gate, the old Gate 1 of the Cape where we came in this morning. You know, the drama may be here at Pad 39 and on the moon this Sunday, that unforgettable drama, but it's somehow, for me, also on the roads around this spit of land which Spanish explorers 352 years ago landed on and called Canaveral, for the fields of sugar cane. That's what Canaveral means in Spanish, cane fields. The fields of sugar cane they found growing here. We passed 10,000 odd cars, what we've guesstimated, parked around the Gate 1 area at 4 a.m. when we got here, cars from every state, with little kids staring wide-eyed at the Saturn V glowing in the huge xenon spotlights 15 miles away. And we saw teenagers with telescopes. It was the very same road we came over 8 long years ago, 21 manned space flights ago, when we came out at just about the same hour to cover Alan Shepard's 15-minute suborbital hop, America's first manned space flight. Americans cared then, I think, and they care now. And it was a very moving scene for me because, well, we were tired. They were tired. They'd been up all night. All those thousands of people who we see now in daylight in those cars parked along the road that our live helicopter is showing us. Indeed, the helicopter pilot this morning, Bob Lockrow is his name, was the same man who used to fly us here with the very first film switches we did on flights and the very first live things. There's good luck Apollo 11 engraved in the sand. All going very smoothly here with the count. Among the distinguished visitors here this morning, along with Vice President Spiro Agnew, is the former President Lyndon Johnson. There's our live picture from the VIP stands on the other side of the VAB and Launch Control Center. Behind the former president is former NASA Administrator James Webb, sitting in the picture, and many other dignitaries gathered there. Some 8,000 dignitaries in all invited by the space agency as guests to be at this launch. And there's Mrs. Johnson being greeted with the former president.
42 minutes and 44 seconds away from liftoff now of Apollo 11, which is about the size of a United States Navy destroyer, as we pointed out to you a bit earlier. It stands higher than the Statue of Liberty, and it is the most sophisticated space vehicle in the world today. It is made up of 5 separate parts. Jules Bergman has the story on it.
Apollo 11 contains the lunar module, or LEM, which will weigh more than 32,000 pounds at launch time. The command module serves as a flight operations center and living quarters for the astronauts. After the third stage rocket sends Apollo 11 toward the moon, the onboard service module engine will be used to put the astronauts into lunar orbit and later to return them home to Earth. The total payload, nearly 100,000 pounds, rests on a Saturn V rocket. The first stage generates 7.5 million pounds of thrust at liftoff. The second stage will carry the Apollo spacecraft and astronauts to an altitude of 100 miles. And then the third stage breaks Apollo 11 out of Earth orbit and propels the astronauts toward the moon. And this is what Eagle, the lunar module on Apollo 11, will look like after its legs are, its gear is put down after translunar flight has begun and as it heads toward the moon. In addition to this black and white covering, of course, it's covered by gold and black thermal foil, if you will, mylar foil, and black foil to protect it from heating as it heads around into lunar orbit and then down toward its descent on the moon. But essentially, that's what the vehicle looks like, a very ungainly machine. The astronauts still call it a thin, light-walled flying machine, a thin, light-walled structure, but it has proven to be one heck of a good flying machine on 2 flights now, Apollo 9 and Apollo 10. Launch control is telling us now that things are proceeding very smoothly with the fueling and with topping off the liquid oxygen in the S1C, the Saturn main stage, all going very smoothly at T-minus 40 minutes, and we're lifting off at 9:32 a.m. Eastern Daylight Time as of now, everything proceeding very smoothly toward that pre-calculated liftoff time.
2 minutes, 10 seconds, and counting. The target for the Apollo 11 astronauts, the moon at liftoff, will be at a distance of 218,096 miles away. We've just passed the 2-minute mark in the countdown. T-minus 1 minute, 54 seconds, and counting. Our status board indicates that the oxidizer tanks in the second and third stages now have pressurized. We've continued to build up pressure in all 3 stages here at the last minute to prepare it for liftoff. T-minus 1 minute, 35 seconds on the Apollo mission, the flight to land of the first men on the moon. All indications coming in to the control center at this time indicate we are go. 1 minute, 25 seconds and counting. Our status board indicates the third stage completely pressurized. 80-second mark has now been passed. We'll go on full internal power at the 50-second mark in the countdown. Guidance system goes on internal at 17 seconds, leading up to the ignition sequence at 8.9 seconds. We're approaching the 60-second mark on the Apollo 11 mission. T-minus 60 seconds and counting. We passed T-minus 60. 55 seconds and counting. Neil Armstrong just reported back it's been a real smooth countdown. We passed the 50-second mark. Power transfer is complete. We're on internal power with the launch vehicle at this time. 40 seconds away from the Apollo 11 liftoff. All the second stage tanks now pressurized. 35 seconds and counting. We are still go with Apollo 11. 30 seconds and counting. Astronauts report it feels good. T-minus 25 seconds. 20 seconds and counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence starts. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
We got a roll program.
Neil Armstrong reporting the roll and pitch program, which puts Apollo 11 on a proper heading.
Slowly, but gathering speed. Going beautifully, burning hot.
Plus 30 seconds.
Roll complete and the pitch is programmed.
One Bravo is a abort control mode. Altitude's 2 miles.
Oh, 11 Houston, you're good at 1 minute.
Downrange 1 mile, altitude 4 miles now. Velocity 2,195 feet per second.
Going beautifully.
We're through the region of maximum dynamic pressure now.
Apollo 11, 42,000 feet.
17 mile pitch range, 12 miles high. Velocity 4,000%.
Stand by on mode 1, Charlie. Mark, mode 1, Charlie. 1, Charlie.
Cliff Charlesworth taking a staging status.
This is Houston, you are go for staging. Inboard cutoff.
Inboard engines out.
I'm inboard cutoff.
inboard cutoff exactly on schedule. Apollo 11 now 3,000 miles, now doing 3,650 miles an hour.
Downrange 35 miles, 30 miles high. Standing by for the outboard engine cut down now.
Station.
Outboard.
And ignition.
Armstrong reporting staging and ignition. The first stage engines have burned out exactly on schedule. The second stage engines have lit off.
Houston, thrust is go. All engines, you're looking good. Hi, Roger. You're loud and clear, Houston.
41
At 3
miles.
minutes, downrange 70 miles, 43 miles high, velocity 9,300 feet per second.
We got skirt step. Roger, we confirm skirt step.
Apollo 11 going a little faster than expected, but perfectly within
Neil
limits.
Armstrong confirming both the engine skirt separation and the launch escape tower separation.
Houston, be advised the visual is go today. This is Houston. Roger, out. Yeah, they finally gave me a window to look out. Houston, your guidance is converged. You're looking good.
Downrange 140 miles, altitude 62 miles, velocity 10,300 feet per second.
11 Houston, you are go at 4 minutes. Roger.
Still in sight from our long-range cameras,
Ground track.
burning hot, straight and true all the way. Toward a moon 218,000 miles distant. A moment many Americans, many people never believed could happen or would happen.
190 miles downrange now, 72 miles high, velocity 11,000 feet per second.
And the first major hurdles have been passed for Apollo 11. All going very, very well. The first minutes of a 195-hour-long flight, ticking off almost without tension, almost like a regular airliner takeoff, but for the thunderous roar, the flame of the Saturn
Booster
V.
says it's looking good at 5 minutes.
11 Houston, you are go at 5 minutes. Roger, Apollo 11, go.
We're hearing Neil Armstrong live, reporting back to booster control, Capcom in mission
Downrange
control.
270 miles, altitude 82 miles, velocity 12,472 feet per second.
Slide S4B to COI capability. Okay.
That's 9,000 miles an hour.
S4B to COI capability.
That's 9,000 miles an hour. Confirmation that the
Apollo 11 could now get into orbit using the S4B if necessary.
Your living room. Thank you. You all are coming through beautifully, too.
very clear communications this morning, very clear air-to-ground from Apollo 11. That's Capcom Bruce McCandless you hear talking from Houston Mission Control. And occasionally Flight Director Cliff Charlesworth in the background. And down...
Everyone's reporting go here in the control center.
So in 6 minutes, starting to get motors.
And our long-range...
Roger 11, you're go from the ground at 6 minutes.
Our long-range cameras have lost the picture finally. Our cameras are now at pad 39, viewing that water deluge or dowsing system we told you about. Hundreds of thousands of gallons of water, saving the pad from being all but wiped out by the heat and the flame. The water is still going, still keeping cool. Our animated view now showing us what's happening up there at 6 minutes and 35 seconds into the flight of Apollo 11.
Between the second stage and the third stage, the fuel uncovers a sensor starting that sequence.
We're coming up almost to the point where the second stage S2 rockets will burn out.
Covered at 8 minutes 17 seconds with outboard engine cut off, 9 minutes 11 seconds on the second stage.
Apollo 11's go at 7 minutes. 11, this is Houston. Roger, your go from the ground at 7 minutes. Level sense arm at 8+17. Outboard cut off at 9+11. Roger.
Very close to
Downrange
nominal figures.
530 miles, altitude 95 miles, velocity 17,358 feet per second.
Apollo 11 has almost reached orbital velocity now. It'll require another minute of burn of the S2 second stage. President Johnson in the VIP stands with Lady Bird Johnson, obviously relaxed,
Apollo 11
happy at the way the launch went, and Vice President Agnew next to the
at
President.
7 minutes, 41 seconds.
Roger, we confirm.
Inboard engines are out on the second stage as planned.
Inboard engine burnout exactly on schedule at 7 minutes, 40 seconds. Apollo 11 now about 3 minutes away from going into Earth's orbit over mid-Atlantic.
Apollo 11, go on all sources.
You are go at 8 minutes.
I've just built the mixture ratio ship.
And galloping
We got
along.
PU shift down here too.
Apollo 11 galloping along now at more than 12,500 miles an hour.
United States Board, these thunderstorms downrange is about all.
That was Neil Armstrong. We couldn't make out what he said.
11, this is Houston. You are go for staging. Over.
Understand, go for staging.
Stand by for mode 4 capability.
Remote 4.
Mark, mode 4 capability.
Mode 4 and Apollo 11 could get into orbit using the service propulsion system now. Altitude is 100 miles, downrange 883 miles. Outboard engine cutoff.
And ignition.
Ignition confirmed. Thrust is go, 11.
And we have a good third stage now.
Third stage ignition on schedule, speed building up just the way it should. Looking very, very good.
Velocity 23,128 feet per second. Downrange 1,000 miles, altitude 101 miles.
Apollo 11, this is Houston. At 10 minutes, you are go.
Roger, 11, go.
Capcom Bruce McCandless giving the reports here from the control center.
A relaxed Neil Armstrong saying, "Ah, Roger, we're go."
Apollo 11, this is Houston. Predicted cutoff at 11 plus 42. Over.
1142, Roger.
Downrange 1,175 miles. Velocity 24,190 feet per second. Altitude 102 nautical miles. Apollo 11 still go on all sources.
Apollo 11, this is Houston. You are go at 11.
And ticking away the last few seconds.
We're predicting third stage shutdown at 11 minutes 42 seconds.
And Apollo 11 is just about ready to go into orbit in a few seconds from now.
Velocity 25,254 feet per second. Downrange 1,400 miles now. Altitude 102.8 nautical miles.
Shutdown.
Shutdown right on time.
1.4 by 103.6.
Roger, shut down, and we copy 101.4 by 103.6.
And Apollo 11 is in orbit. Scratchy.
Apollo 11, this is Houston. You are confirmed to go for orbit.
When the third stage is fired, the astronauts will then be inserted into an Earth parking orbit.
The guidance system has already computed the trajectory needed to intercept the moon. The confirmation of that trajectory or course will be relayed by Houston to the astronauts. 2 hours and 40 minutes after launch over the Pacific, the third stage engine will be restarted, and when an escape velocity of nearly 25,000 miles per hour is reached, Apollo 11 will be injected into a translunar trajectory. Soon after, the panels of the spacecraft's lunar module adapter are jettisoned. The Apollo Command and Service Module then separates from the booster. The astronauts start the docking maneuver, rotating Apollo 180 degrees, and then, using their small thruster rockets, dock with the LEM. The third stage will be jettisoned when the docking maneuver is completed about 2 hours after translunar injection. The astronauts, using star sightings backed up by mission control, guidance radar, and computers, then work up the data to make mid-course corrections and set their course to intercept the moon 3 days later. Depending on how accurate the rocket engine burns to get away from Earth, none or as many as 3 mid-course corrections may be needed. Apollo's speed decreases from 25,000 to less than 4,000 miles per hour en route. Then, near the moon, as lunar gravity begins to exert its influence, the speed of the spacecraft increases up to 6,000 miles per hour. Apollo 11 is in a free return trajectory, which will carry it around the moon and back to Earth for recovery if problems have developed. But if all has gone well, Apollo 11's onboard service module engine will be fired, and the spacecraft will be placed into lunar orbit. Because of the danger of mechanical failure, all of the systems can be overridden by the astronauts if the automatic systems aren't working perfectly. 81 hours into the flight, Armstrong and Aldrin transfer into the lunar module for the second time, completing their checkout of the lunar landing spacecraft. They remove the docking probe and drogue from the tunnel connecting the command and lunar modules and equalize the pressure in both vehicles. The lunar module pilot then floats through the docking tunnel overhead and into the LEM. One of the first tasks for the lunar module pilot is to activate the LEM's environmental control system and to change his suit connections to the LEM's umbilicals.
Now, today the moon is the target, and we're going to get the word on that TLI burn coming up in just a moment now from mission control. And we're now 14 seconds away from TLI burn. Mission control is counting down. There's ignition. There's the word from mission control. Ignition over the South Pacific for the translunar insertion burn.
We confirm ignition, and the thrust is go.
The thrust is built up to get them headed up to escape velocity speed of 25,000 miles an hour. The burn took place over the southwestern Pacific 2 hours and 24 minutes into the flight of Apollo 11.
Guidance looking good.
Let's go to mission control now for the talk down to the separation maneuver.
This is Houston, we copy.
We have Tom McCandless saying he copied, but very faint transmission. Let's see if we can pick it up now.
We confirm the separation here on the ground.
Separation confirmed. The third major hurdle of the flight accomplished. Next, that docking and extraction of the LEM.
All right, we now have a picture from Apollo 11, so let's go to Houston for the conversation between the spacecraft and Houston, and we'll see these pictures. There's the Earth.
The Earth from 130,000 nautical, or about 149,000 statute miles.
Roger, you're seeing Earth as we see it at our left-hand window, just a little more than a half Earth. We're looking at the eastern Pacific Ocean. In the north half of the top half of the screen, we can see North America, Alaska, United States, Canada, Mexico, and Central America. South America becomes invisible just off beyond the terminator or inside the shadow. We can see the oceans with a definite blue cast. See white bands of major cloud formations across the Earth, and can see pick out the western U.S., San Joaquin Valley, the Sierra Mountain Range, the peninsula of Baja California, and can see some cloud formations over southeastern U.S. There's one definite mild storm southwest of Alaska, looks like about 500 to 1,000 miles, and another very minor storm showing the south end of the screen near the, a long way south of the equator, probably 45 degrees or more south latitude.
We were saying, Cliff Charlesworth, that
we can still see the Earth through the left window, and it appears that we can see a floodlight off to the left, either that or some sun shafting through the hatch window.
Almost looks like two Earths.
It's floodlight. Now we're coming in. Can't quite make out who that had. It's Big Mike Collins there.
Well, you got a little bit of... Yeah, hello there, sports fans. You got a little bit of me, plus Neil's in the center couch, and Buzz is doing the camera work this time.
Roger, it's a little dark now, 11. Maybe a bigger f-stop might help.
Yeah, that didn't work.
It's getting a lot better now, 11. Mike, you coming in 5 by, got a good...
Well, I put on a coat and tie if I'd known about this ahead of time.
Is Buzz holding your cue cards for you over?
Cue cards have a no. We have... comfortable up here, though. We do have a happy home. There's plenty of room for the three of us, and I think we're all learning to find our favorite little corner to sit in. The 0G is very comfortable, but after a while you get to the point where you sort of get tired of rattling around and banging off the ceiling and the floor and the side, so you tend to find a little corner somewhere and put your knees up or something like that to wedge yourself in, and that seems more at home.
Roger, looks like Neil is coming in 5 by there. 11, Mike, see you in the background. The definition is really outstanding. The colors are good. It's a real good picture we're getting here of the Commander Armstrong.
Neil's standing on his head again. He's trying to make me nervous.
Roger.
He's disappearing up into the tunnel, of course, as he would going into the lunar module, only backwards.
Roger, we can see portions of the LAP now, the systems test meter panel in the lower part of the picture, or we did have it anyway.
Okay, and then directly behind his head are our optical instruments, the sextant and the telescope that we use to take sightings with.
Roger, copy, and we see the disc keep flashing with a 651. Like we can read registers 1 and 2 quite clearly.
That's the computer.
Yeah, the old high gain angles telling us which way the Earth is.
Sure. Read the numbers.
Copy. That's a beautiful picture. Clarity is outstanding.
We can also give you the time of day in our system of mission elapsed time, 34 hours, 16 minutes, and 15 seconds.
Roger.
Can you see that clearly enough, Charlie?
Roger, Apollo 11. We can see it counting up every second. We got 3417.02 now.
Okay, back to the high gain angles.
Roger.
Swing amp. Now we've amputated those.
The best quality picture we've ever seen from the inside of a spacecraft.
Yeah, you able to read those numbers like that, like a chalkboard at a racetrack.
Even if it is their computer display keyboard or disk key readout.
11, Houston, we have a beautiful rainbow there, and as you move the camera around, that looks like the star chart coming into view now, over.
Yeah, those are Buzz's two star charts that he is using right now as sunshades over the right-hand window, window number 5.
Roger, we see the sun shining in through it behind him and plotting out the the ecliptic plane and the stars that you're using for the navigation.
You're right. He doesn't really need the charts. He's got them memorized. They're just for show.
We copy.
Well, we're pointing up in this direction. We see out our side windows the sun going by, and of course out one of our windows right now we've got the Earth. Now right behind my window, of course, we have the sun, because the sun is illuminating the star chart that we see. This line represents the ecliptic plane, and these lines, vertical lines, represent our reference system that the spacecraft is using at this time. As we approach the moon will gradually grow larger and larger in size, and eventually it will be in eclipse. It will be eclipsing the sun as we go behind it as we approach the lunar orbit insertion maneuver.
Roger, 11. Could you attempt a little bit better focus there, 11, over?
Like Mike Collins is moving the camera around the inside of the spacecraft again, back to Buzz Aldrin's star charts.
Now, Aldrin's the only one we haven't seen. He was talking just a moment ago, but we haven't seen him yet.
So part of the smooth pate of his semi-bald head.
11, Houston, that's a lot better on the star chart now. We can make out the ecliptic plane and the planets and the sun and the moon as they're drawn at various places throughout the ecliptic plane, over.
Okay, Charlie.
There's Aldrin.
Slightly out of focus shot and a little audio breakup beginning.
If we can get some of the wires untangled here, we'll give you a demonstration of how easy push-ups are up here.
Over, Roger. Good view of Buzz there.
One of the reasons these pictures are such good quality is they're using a small floodlight inside the cabin to help illuminate their faces and the instruments.
When it gets pretty hard doing it that way, why we just roll over and do it the other way.
Roger, we copy. Couldn't figure out whether that was a chin-up or a push-up. Just take your choice, I guess.
Buzz Aldrin going through a complete roll now in weightlessness. floating his way forward in the cabin from the lower equipment bay.
Here's the champion full,
Well, looks like it's probably almost your dinner time down there, Earth. We'll show you our food cabinet here in a second. 11, roger.
You know, Frank, in weightlessness, even I could be a champion acrobat. It doesn't take a Buzz Aldrin. And now we're looking in the left-hand lower equipment bay where the food is stored and prepared. It's probably Mike Cullen.
Houston, we see a box full of goodies there, over.
Oh, we really have them, Charlie. We got all kinds of good stuff. We've got coffee up here in the upper left and various breakfast items, bacon in little small bites, and beverages like fruit drink. And over in the center part, we have all kinds of things. Let me pull one out here and see what it is.
Right.
Would you believe you're looking at chicken stew here? All you have to do is 3 ounces of hot water for 5 or 10 minutes. Now we get our hot water out of a little spigot up here with a filter on it that filters any gases that may be in the drinking water out. And we just stick the end of this little tube in the end of the spigot and pull the trigger 3 times for 3 ounces of hot water, and then mush it up and slice the end off it. There you go, beautiful chicken stew.
Sounds delicious.
And that's their little emergency flashlight.
Yeah, the food so far has been very good. We couldn't be happier with it.
Roger.
That flashlight a second?
The surgeons are saying thank you there for that.
And it is sort of down in a dark corner, so we have a flashlight here to help us see things. And if I can let go of it carefully, it'll just hold itself right where it is.
Roger.
As long as disturb it will.
Apollo 11, Houston, that's a pretty good demonstration. You started out really stable there, Mike.
Well, the problem is no matter how carefully you let go, you bump it just a tiny little bit, set it in motion, and once in motion, there she goes. Try that again.
It looks fairly stable now with slow rotation.
A little 13-pound portable TV camera shooting these pictures handheld by the astronauts themselves. Now more than 130,000 miles out in space.
I sent their compliments to the chef this afternoon about the salmon salad, which should make salmon fishermen
Well,
very
so much
happy.
for the food department. I'm going to close up the store down here.
Roger, we copy.
Charlie, we checked out the cable lengths, and we're thinking we might want to see if we can take the TV into the LEM with us tomorrow for part of the time. Over.
Roger, good show. We'd like to see it if it'll reach that far, over.
We'll give it a try.
Raj.
And we're seeing Mike Collins closing up the food locker. That was Buzz Aldrin we heard, saying they might take the camera up into the lunar module tomorrow. It's 56 hours into the flight when they check it out for the first time.
Clear definition there of Collins' face.
The camera has been clamped on using some small hand clamps they use for their still picture cameras and motion picture cameras.
Now, where I sleep is down underneath this couch.
Houston, Roger.
And Mike Collins is apparently about to show us a demonstration of his sleep station.
Slowly sinking into the sack there.
Yeah, it's really comfortable. give buzzing flashlight back.
They carry some 7 of those little emergency flashlights, Frank, which are really meant as survival flashlights in case they come down on the water and are stranded at sea at night. But they end up using them for everything.
Well, the one question that is raised most often, over and over again, talk about redundancy, is why go to the moon? Well, for scientists, of course, the answer is obvious. They feel that the unexplored moon, thus far unexplored, will tell us many things about our Earth that we cannot find out by studying the Earth itself. In making it a comfortable place to live here, we have more or less wiped out its early history. One of our guests throughout our Apollo 11 coverage, we've already heard from him today, is Dr. Robert Jastrow, who is director of the Goddard Institute for Space Studies at Columbia University. We put the question to Dr. Goddard, why go to the moon?
The moon is a poor piece of real estate, and probably lifeless. But for precisely that reason, it is scientifically invaluable. We would like to know what conditions were on the Earth in the first billion years of its history, about 3.5 billion years ago, when life appeared on this planet according to the fossil record. We'd like to know how the solar system was formed and how the Earth itself was formed. These are things that we would like to know in order to understand whether we are probably unique in our human experience in this part of the world or this part of the universe, or whether what we are experiencing on our planet has been gone through many times in many places. Now, unfortunately, this early history of the Earth has been wiped out by the very factors on our planet that make it such a comfortable place to live in. We have running water, and we have wind, atmosphere. They erode all of the record of our past. We have mountain building, which creates the beautiful continents, but it also wears out and turns over and churns around the record or the rocks that were laid down here when the Earth was a young planet. The very life that we have has removed the traces of its own origins. On the moon, however, which we think is probably lifeless, there's no atmosphere, there's no running water at the present time, and we think that the record of its past is infinitely better preserved than it is on the Earth. Just looking at a picture of the moon such as this one shows you countless craters, the scars of meteorite impacts that have occurred throughout the moon's history. There are 100,000 of them or so visible in a telescope on the front face of the moon alone. Now, these craters, which were probably formed by meteorite impacts, have also, or must also, have occurred on the Earth. The same bombardment by meteorites must have occurred. There are, however, very few remains of those craters left. One of the few remaining is the Arizona crater, a crater 4,000 feet across that you can see when you fly, let's say, from New York to Los Angeles in a jet. This is one of 20 or so craters that are still visible on the face of the Earth. The other hundreds of thousands of millions have been worn away and turned over and buried. Because of the fact that these craters still remain on the moon, but are gone from the Earth, we are pretty confident that the moon's surface goes back farther than the surface of the Earth. Just as a digression, by the way, I'd like to mention that there was a big dispute among scientists until recently over whether the craters on the moon were volcanic or meteorite impacts. I think most people believe that while some of these craters are volcanoes, the majority of them are meteorite impacts. And the reason I believe that can be demonstrated in the studio. When a meteorite comes into the surface of the moon, it has so high a speed that its energy per pound is 5 or 10 times that of TNT. It drills a clean hole in the surface of the moon and buries itself underground, driving a plug of moon rock ahead of it at such a great rate that the plug of rock is compressed and heated to a gas, a vaporized rock gas. When the meteorite comes to rest, then this plug of hot gas explodes, ejecting all the material above it and forming a crater, something like a bomb crater. Bomb craters have exactly the same size and shape as most most craters on the moon, and we think, therefore, that moon craters are bomb craters. I can't explode a bomb in the studio, but I have buried a firecracker in a bin of sand to produce a small crater of the kind you can see in surveyor photographs of the moon, and a crater which in minuscule form has the dimensions, the scaling, and the shape of of lunar craters and bomb craters on the Earth. That was very satisfactory because it shows not only the characteristic conical shape of many lunar craters, but it even shows the lip that forms around them and the bits of debris, in this case they're chunks of flour, that litter the field, and it shows these rays, these radiating lines of light material by which scientists always are able to recognize freshly formed new craters on the moon. In particular, this little explosion crater looks just like large bomb craters and like most lunar craters. So I think there's no doubt what the origin of lunar craters, of many of them at least, is. That doesn't exclude the fact that some craters are volcanic, but that's another story, that's another matter. Now, there's a very interesting consequence of the fact that many craters on the moon are explosion craters formed by meteorites. I have a picture of a 500-foot crater which happens to be in the Ocean of Storms on the west limb of the moon. It's actually in the mouth of the face of the man in the moon when you look at him in the sky. And you see in this crater a littering of the field, of the ocean surface around it, with chunks of rock, some of them 10, some of them 20, 30 feet in diameter. The significance is that when we land on the moon, in each of our landings, although the exploration or the region explored is quite small, perhaps the size of a garden plot in the first landing, we will probably find on that garden plot an accumulation of debris, as shown in the next photograph, the surveyor photograph, taken of a region on the moon similar to the regions in which the landings are occurring. We will find an accumulation of debris, as you see in this picture of the moon surface, representing rocks hurled out of craters all over the moon, rocks from all ages of the moon's past, all depths, all places. An excellent sample of the whole moon acquired from the exploration of one small territory. At least we will be finding these things, this variety, if we're lucky. What will we do with these samples of rocks when we get them? Well, the key question always, I think, in discussing the scientific interest of the moon is, does any part of its surface go back to the missing billion years of the solar system's history and the time in which life appeared on our own planet, or does it not? How old is the surface of the moon? There's much controversy on that question. Some of us hope or expect that parts of the moon do go back to that first missing billion years. And partly with this motivation, among the experiments performed on the lunar rocks as soon as they are let out of quarantine in Houston, the single largest block, about 30 or 40 experimental groups here and abroad, will be concerned with dating these rocks. They're dated radioactively using the fact that all rocks on the Earth, and we're pretty sure on the moon, contain trace amounts of radioactive substances such as uranium. They're present in very, very minute traces, I think a few parts per million, but nonetheless enough so that the radioactivity can be detected if one has a Geiger counter. I have one here. It's connected to an amplifier and a microphone so that it gives a visible click every time it's triggered by the passage of an energetic particle through it. You can hear it click once in a while as I speak because a cosmic ray has passed through it. I also have a piece of rock which contains not invisible amounts, but in an invisibly small amount, some radioactive uranium. And as I bring this rock up to the Geiger counter, the proof of the existence of that radioactivity in the rock is in the fact that an absolute cascade of counts comes out of the counter, almost drowning my voice. This radioactivity itself is not the main point. It is not the means used to date the rocks directly. That's done in the following way, that whenever a radioactive uranium atom decays, emitting one of the particles that we just heard being audibly detected by the counter, it is transformed into a new nucleus and eventually winds up as lead. If the rock is very old, most of the uranium in it has been converted to lead. And when you measure the ratio of uranium to lead by delicate chemical analyses, you find very little uranium and a lot of lead. If the rock is young, very little of the uranium has been converted, and when you measure this ratio, you find mostly uranium and very little lead. So the ratio of uranium to the lead it produces by decay measures the age of the rock. We hope when we make that measurement, our experimenters, that they will find some samples whose ages turn out to be 3.5 billion years or more, and supply us with information on the missing pages of the Earth and the Moon's history. And that will be the greatest scientific prize that we can possibly capture from the lunar exploration. So the paradox of the Moon is that precisely because it is a poor piece of real estate and probably lifeless, with little or no water, for that very reason it is likely to have preserved the record of its past better than the Earth. And in those samples, we hope or expect that we will find clues to the origin of the Earth, the origin of the solar system, perhaps even the conditions under which life began on the Earth, and organic molecules that give us a hint of the way in which life evolved out of non-living chemicals on this Earth, if that's the way, in fact, in which it happened here. The surface of the Moon can be the Rosetta Stone of the Earth and the solar system and reveal the answer to ancient mysteries.
Now, here in New York is ABC News commentator Frank Reynolds.
And good afternoon from ABC Space Headquarters in New York. With me is our science editor, Jules Bergman, and we are on the air today to bring you a complete report on some very, very important maneuvers to be performed by Apollo 11. Basically, the spacecraft is now about 1,000 miles from the Moon and is about to move into position to begin the process that will eventually lead to the landing on the Moon tomorrow afternoon. In less than 15 minutes or so from now, Apollo 11 moves behind the Moon to the dark side, and we will then lose voice contact with the astronauts. And after about 6 minutes or so, then we will have this first big burn of their main engine aboard the spacecraft that will put them into orbit around the Moon. Jules, this is where it becomes very, very interesting, right?
Right, Frank. About 19 minutes from now, Armstrong, Aldrin, and Collins will fire up their big SPS, or Service Propulsion System engine, a 20,500-pound rocket engine, to slow Apollo 11 so that it's captured by the Moon's gravity. It's a walloping big rocket engine burn, consuming more than 7 tons of fuel and propellant. And it slows the spacecraft, both the CSM and the lunar module are docked together, from their speed at that time of nearly 6,000 miles an hour to 3,700 miles an hour. It's a tricky time. Armstrong, Aldrin, and Collins are on their own. Behind the Moon, we can't hear them. Mission Control can't hear or see them. There's the Moon turning, and Apollo 11 is swinging up like this in its orbit. It's coming up behind the Moon just about at this time. Now, that orbit will carry them about 70 miles behind the Moon if nothing at all is done, if they don't do the lunar orbit burn. If they do it, and they're turned around in a retrograde position for a braking burn, if they do it, they descend closer to the Moon like this and are captured by the Moon's gravity, and then swing around the Moon any number of times like that. In point of fact, 13 times until they get set for the descent maneuvers and the landing tomorrow, as they come around the Moon at that time.
Yes, later on this afternoon, then they'll make another orbit burn, won't they, to come down still lower?
Right. Now let's look at what's going to happen if the LOI burn shouldn't work. They would come up behind the Moon just like this, as they are, where they'll break up there, and swing back to Earth just like that, and land in about 45 hours from this afternoon. There's no reason to think that's going to happen. We're coming up very close now on the scheduled lunar orbit burn time, and this is the way it would look through our simulation inside the Apollo 11 cockpit at this time. Armstrong, Aldrin, and Collins going through the enabling maneuvers. Here's Apollo control.
49 minutes. Apollo 11 should have started this long burn. Duration 6 minutes, 2 seconds. Delta V 2,917 feet per second. Given that burn, we expect an orbit of 61 by 169.2 nautical miles. Madrid, AOS. Madrid, AOS.
That's officer from the grid tracking station has acquired signal. And we're hearing Armstrong very faintly in the background, too faintly to understand. Capcom McCandless calling Apollo 11, saying, Apollo 11, do you read Houston?
We are reading you weekly. Go ahead.
That's Bruce McCandless calling. It. That was Neil Armstrong reading back his remaining fuel and burn times to Houston. Very scratchy radio communication. The antennas still aren't set, but Armstrong and his crew are obviously in good shape. The LOI burn went perfectly.
As we were saying a short while ago, while we were waiting really to acquire the signal from Apollo 11, Russia's Luna 15 has moved into a slightly higher orbit around the moon. They have, of course, promised to notify Frank Borman that Luna 15 would not in any way, well, they promised to notify him in the event of any substantial change in the flight plan of Luna 15. They have still, of course, not volunteered any information about the ultimate mission of Luna 15, and we don't know yet whether they really do plan to go on down and scoop up some moon rocks and get back to Earth with them before the men of Apollo 11 can do the same. But the Russian flight is, of course, unmanned. We might just go back into history here a bit and recall that day of April 12th, 1961, and our reaction to the Soviet triumph of putting the first man in space. We've looked back to that day quite often since then. Our space triumphs have wiped out, I think, any vestige of humiliation the United States might have felt at that time, but not the memory of it. Here is an excerpt from a program that ABC News did at that time in 1961 with a youthful science editor named Jules Bergman. Look for the Russian animation explaining how they planned to get to the moon. It seemed quite practical 8 years ago. And here is how ABC News noted the one-orbit flight of Yuri Gagarin, the first man in space.
Historic day, one of the most unforgettable of our century. The point of departure for man seeking to reach space. And this man, Yuri Gagarin, major in the Soviet Air Force, is the first to cross the frontier into the unknown of space. 27 years old, quasi, handsome, highly trained, married to a medical student, the father of 2 girls. Occupation, cosmonaut, the world's first. He has now traveled faster, higher, and farther than any man in the history of this planet. And no other man can yet claim the same occupation or distinction. Tonight, all Russia has gone wild with joy. Delirious crowds in the streets of Moscow, Leningrad, and other cities, hailing the triumph of Soviet science over the West. Russia calls it an unparalleled victory of man over the forces of nature, an immense achievement of science and technology, and the triumph of the human mind. And it is indeed all these things. Now the world is asking, what next? What will Russia try to conquer next in this new world of space? This is what the Russians have in mind for us, a film preview of the future from Soviet science. We're looking at a portion of an extensive film animation prepared by the Soviets of a projected trip to the moon, one they claim will be a reality in the next 5 to 10 years. At the beginning of such a flight, a spaceship propels a multi-stage rocket. As the speed increases, the rocket breaks away, and then various other stages of the rocket also fall away. After a time, it is traveling by inertia alone with no further energy required. Powerful radar stations keep the rocket within the grasp of its radio signals. And automatically operated instruments on the ground send radio impulses back to the rocket from the Earth. And they're received by ground stations. This station guides the rocket with the help of machines to count the electronic impulses. The rocket races forward along an orbit that has been calculated months in advance. But at a command from the Earth, it can launch into another orbit. When the rocket has traveled beyond the Earth's gravity, it can head toward its goal, the gravitational field of the moon. Now a refueling rocket sets out from the Earth, and now our rocket is headed into the moon. When it reaches the moon, a laboratory and tank treads will launch out to explore the moon. The Soviet scientists who designed this project describe it as fully possible. And it may be the next step for the Russians. And so the pattern of Soviet triumph in space. Where are we ask tonight. Our Project Mercury will get off the ground in its first short manned shot near the end of this month. A short ride, 115 miles to the edge of space. April 28th is the earliest date. As for an orbital flight, like Russia did today, that won't come until near the end of the year, maybe not even until early next year. And how do our Mercury astronauts feel about the Soviet triumph? Disappointed, they all tell us today. Naturally, we wanted to be first. 10 days ago at Mercury headquarters, Langley Field, Virginia, I asked Lieutenant Colonel John Glenn, who may well be our first astronaut into space, how he would feel if the Russians beat us into space.
John, if the Russians get a man up before we do, how would you feel about that?
Well, that's a good question because we've been asked this many times. There's only one answer to that. It doesn't change our program one bit. This is like saying that because Henry Ford started a new car first, no one else should be in the automobile business today. The General Motors should have dropped out before they started. Well, this is ridiculous, of course, and it's probably a ridiculous example, but the fact that the Russians happen to get a shot off or may not get a shot off a little bit before we do doesn't alter the objectives of our program a bit. Our program is not set up just as a race to space. We're well aware of the international implications of this, but this doesn't alter the step-by-step progression that we want our program to go through to see that man safely starts space exploration. We have our goals, I guess they have theirs, and the fact that they do or do not get a shot off ahead of us will not alter the objects of Project Mercury.
We're not going to change our plans.
No.
And good afternoon once again. We are, in fact, about to see more pictures now from of the lunar surface from Apollo 11. With me here in our space headquarters in New York is our science editor, Jules Bergman. Jules, these should be interesting shots.
Frank, Apollo 11 is now on the near side of the moon, coming up on the Sea of Tranquility, the landing area where Armstrong and Aldrin are scheduled to land tomorrow at an altitude of 102 miles, and we're just getting the TV picture. Let's go to it for Apollo control.
Apollo Control, Houston. We acquired TV at 78 hours, 24 minutes, 11 seconds. Currently, our orbital parameters show 104. Altitude, an apolloon of 170.2, a paraloon of 61.3 nautical miles, those are.
Well, this is Houston. Would you care to comment on some of these craters as we go by?
Roger, we're approaching the approach path to ignition. This is equivalent to 13 minutes before ignition, and we're at about 80 degrees east, I guess. 83 degrees east. Would that correspond to location you're holding in, present?
Roger, we're showing your present position is about 76 degrees east, looking back towards the east.
You should be looking back at my Zeno.
Roger.
And
We've now heard from all three Apollo 11 crew members during this television pass. The individual talking earlier was Neil Armstrong.
Ranger Schubert. And Gilbert U is in the center right now.
And this comes up at about a little over 12 minutes for power descent. Instead of looking back at it, we'd be looking straight down at it at that time.
Apollo 11 now flying.
I'll show you an altitude now of about 110 miles, and of course you'd be considerably lower at the initiation of power descent.
This is exactly the same territory. Eagle, the lunar module, will be flying over tomorrow as it begins its power descent toward a landing on Lunar Landing Site 2, now about 100 miles to the west of where we are.
Look at register 3 on the Disky theta. Theta is increasing toward my desired of 315, and I'll let the hand controller alone here, and I'll bet you it reverses itself.
They're just now passing out of Smythe Sea, heading along the lunar equator toward the Sea of Tranquility. And we should be seeing the craters Gilbert and Kastner shortly to the south of their flight path.
Roger 11, we're watching the Disky now, and still coming in beautifully on the TV.
The spacecraft faced around backward, looking back.
Right side of the screen at the present time, there's a triple crater with a small crater between the first and second, and the one at the bottom of the screen is Schubert Y. Zoom in, it does have a central peak in Schubert Y. Actually, several of them, and you can observe those. But the rim craters at the bottom of your screen.
Roger, we're seeing the central peak quite clearly now.
Our view of this tomorrow will be much closer, of course, and be down a good deal closer to the lunar
Okay,
surface.
we're zooming in now on a crater called Schubert N. Schubert N, very conical inside walls, and the bottom appears to be nearly flat. Look at data on the Disky. It's stabilized and is holding steady now.
Roger.
Looking out the window, I can see a number of small craters on the bottom of Schubert N. We're coming up on the foaming sea, where I'll be doing some P-22 marking on a crater of my choice, name of Crater Camp.
Okay, we'll be watching for Camp.
And notice register 3 has reversed itself and is heading back the other way now without any pitch thruster firing.
Roger, Mike. We confirm that you've changed the direction of your pitch rate.
Looking directly down on the moon from 100 miles over it as they move out of Smythe Sea into the foaming sea on their way toward the Sea of Tranquility.
Speaking, the tendency seems to be to pull the LEM down toward the center of the moon as in a gravity gradient experiment.
Roger 11, we copy.
Or may have something to do with mass times, or may...
Roger, we've gotten...
may have something to do with mass times, or it may just be the peculiarity of the Disky display.
Okay, we've observed the behavior of your Disky, and I think we've got the data here to work on it. Let us grind around a little while on it, and we'll report back to you probably in a rev or two.
Okay, well, in the meantime, I'm going to pitch down toward 315.
Roger.
That's Mike Collins, who's flying in the left-hand seat. Spacecraft Commander Neil Armstrong's ordinary seat.
Three horizontal craters that you now have in the field of view are immediately underneath the ground track. The right
And then the largest crater that you see is Dubiago P.
It's Armstrong talking.
Roger, we concur on the identification of that crater.
Arago B. That's the crater Neil Armstrong has identified. A small crater, as lunar craters go, one about 4
We
miles.
show you coming up on landmark Alpha 1 here shortly.
Roger, Mike having his first look at Alpha 1 at the present time.
These landmarks, like Alpha 1,
Yeah, it's a great, bright crater. It's not a large one, but an extremely bright one. It looks like a very recent, now it gets impact crater with rays streaming out in all directions, which should make my correction of foaming sea easy to see coming up on it. Now, Crater Cap is one of the smaller ones out on the floor of the foaming sea.
We've been some 17 minutes now into this television pass, standing by, continuing to monitor.
they're now about 80 miles east of landing site 2 in the Sea of Tranquility, moving past the crater Kant, which you saw a moment ago.
This view is from about 110 miles up, too.
That's right. They've reached their low point, or parasyncian around the moon, and are heading up toward the high point. And
Take it over the television camera. Look at that
Here we show you
clarity.
over the Sea of Fertility now, and ought to have Langrenus down south of Trek a few degrees, about 9 degrees south of Trek.
Yeah, the crater that's in the center of the screen now is Webb. We'd be looking straight down on it at about 6 minutes before our descent. It has a relatively flat bottom to the crater, and you can see maybe 2 or 3 craters that are in the bottom of it. On the western wall, the wall that's now nearest to the camera, near the bottom of the screen, we can see a dimpled crater just on the outside. And then coming back towards the bottom of the screen and to the left, you can see a series of depressions. It's the type of connected craters that give us most interest to discover why they're in the particular patterns that they're in. I'll zoom the camera in and try and give you a little closer look at this.
Roger, we're observing the dimpled crater now. The central peak that we can see on the orbiter photos doesn't seem to stand out very well here.
Well, they're not central peaks, they're depressions in the center.
Roger.
And you'll notice on the pitch structure activity, I put in a dozen minimum impulses and pitch down, and I'm still far from correcting back to 315. We're moving the camera over to the right window now to give you Langrenus. It's several central peaks, and
Roger, we got Langrenus in our screen now.
And Langrenus is an enormous crater about 160 miles south of their flight path, a crater about 85 miles in diameter. And that's Collins and Armstrong zooming in the camera for a close-up view of it.
Okay, 11, this is Houston. We're getting a beautiful picture of Langrenus now with this rather conspicuous central peak.
Moving along into the Sea of Fertility.
Fertility doesn't look very fertile to me. I don't know who named it. Well, it may have been named by a gentleman whom this crater was named after, Langrenus. Langrenus was a reasonably accurate maps of the moon.
Roger, that's very interesting.
I'll have to admit it sounds better for our purposes than the Sea of Crises.
Amen to that.
Okay, it looks like you're coming inside now on the camera.
Well, I can't get behind the steeple monitor. I'll bring the focus in, but we're going to be looking down past one of the LEM quads, and one of the antennas almost straight down at the ground track that we'll be seeing coming in. Now, I guess this is maybe 2 or 3 minutes before power descent.
That's Lunar Module Pilot Buzz Aldrin telling what we'll be seeing outside the window here of some of the LEM's thruster quads, or little reaction control system engines.
All right, that should put the LEM structure about in focus. I'm going to move it out to infinity and then expand the field of view.
That's Buzz Aldrin, and we're looking at one of the LEM reaction control system quads. He's now zooming past it.
Crater Secchi is out my window now, window number 2.
South Apollo 11, this is Houston. We show you coming up on the Terminator at 78:53, about 7 minutes from now. And we've also got the LOI-2 and TEI-5 pads ready for you after the TV, whenever you want to terminate over.
Roger.
And we're getting a good view of the track leading into the landing site now.
Apollo 11 sweeping along at about 3,700 miles an hour over the moon.
How far are they from the landing site now?
Okay, it looks like we had Secchi K go by about 10 seconds ago, coming up on Apollo Ridge.
And they're now about 300 miles.
And in the right-hand portion of our screen right now, we can see Messier, Alpha, and Bravo with the light-colored rays streaming off in one direction.
Capcom Bruce McCandless saying what Apollo Control sees from the same TV picture we're all looking at.
I don't know if you can make out, but in the Sea of Fertility, there are a number of craters that are just barely discernible. Old craters whose outlines are just barely able to be seen.
Roger, I think we can make them out. The color really enhances our ability to discern features and craters over what we see in real time on our black and white monitor.
All right, at these low sun angles, there's no trace of brown. It's now returned to a very gray appearance, and like the aqueous says, it has a look of plaster of Paris to it at this sun angle, which is completely lacking at higher sun angles.
Roger.
We're now some 25 minutes into our television test.
And shortly, just along here,
This is very close to ignition point for power descent. Just passing Mount Maryland. That's a triangular-shaped mountain that you'll see in the center of the screen at the present time, with the crater Secchi Theta on top of the far northern edge of the mountain. We're getting a good view of Mount Maryland and of Secchi Theta.
that was Neil Armstrong. They're about 260 miles east of the landing site, just about the point, as Armstrong was saying, where they'll ignite the LEM's descent engine tomorrow to begin their landing.
What we call Boot Hill.
occurs 20 seconds into the descent.
And it's easy to see what's on Armstrong's mind.
Watching this pass with a great deal of interest in Mission Control Center is Pete Conrad, the commander for the Apollo 12 mission.
Right edge of the screen, Censorinus T. Now passing the 1 minute point in power descent.
Roger, and for your information, your current altitude is 148 nautical miles above the surface.
The clustered Censorinus craters.
I'm unable to determine altitude at all looking out the window. I couldn't tell whether we're down at 60 or up at 170.
I bet you could tell if you were down at 50,000 feet.
I wouldn't be surprised.
The clustered Censorinus craters will be hearing more of tomorrow right along their flight path as they do the power descent burn.
Some steep ridges here, the edges of old craters that were photographed by Apollo 10, and the crew of Apollo 10 was very impressed with the steepness of these ridges when they came over them at about 50,000 feet.
Roger, we can observe they're also steep even from this altitude. You've got quite a shadow being cast by the sun at these low angles.
The entire surface is getting considerably darker than the surface that we looked at previously when the sun was quite high above us. The crater in the bright crater in the center of the screen, the smaller one, is Censorinus.
Roger, we show you a little over 1 minute from the terminator at the present time.
Censorinus, a crater about 18 miles in diameter. And what Armstrong is doing is flying right down the glide slope.
The picture you're receiving, I think we ought to open up the f-stop some as we approach the terminator.
Yeah, the brightness is still doing quite well. You can go ahead and open it up a stop or two. The automatic light level compensation seems to be working beautifully.
It's going to get dark at about the same time they pass over landing site 2 as they hit the terminator.
That's a good picture of Boot Hill.
One of the landmarks into the site.
3 minutes and 15 seconds into the descent.
Roger, we're seeing Boot Hill now.
The next crater coming into the bottom, that's Duke Island right there, and to the left, the crater, the largest of the crater near the center of the picture right now is Maskell and W. This is a position check during descent at about 3 minutes and 39 seconds, and it's our downrange position check and cross-range position check prior to yawing over face up to acquire the landing radar. Past this point, we would be unable to see the surface below us until getting very near the landing area.
And what Neil Armstrong is saying is that at this point,
you get a real good look at that tomorrow afternoon.
we won't see it this way tomorrow afternoon, of course, because the little TV camera inside the command module won't be with them.
Continuous reel is the one that was referred to in Apollo 10 as Sidewinder. Good name, too. Sidewinder Diamondback. Looks like a couple of snakes down there in the lake bed.
They would now be at about 37,000 feet over the moon if they were in the landing procedure.
And we're approaching the Terminator now. You see the contrast increase. and only the sunlit side of the bridges remain illuminated, while the dark sides in the shadow will become completely black.
11, this is Houston. The picture is getting a little grainy now. You might go ahead and open up the f-stop.
Landing point is just barely into darkness. That one crater, the upper part of which you see, lower part completely in darkness. A small, well-defined crater is Mulkey, which is about a beam of the landing site.
Roger, we can just see it looks like a little less than half of its rim right now.
And it would appear that the orbit of Apollo 11 is perfect.
Just barely some features on the surface, maybe from Earthshine.
The crater Mulkey there, about 30 miles south of their track.
Are you wide open on the f-stop at this time?
Where we are. Yeah, and it looks like we're just about to get the sun coming into the lens, so we'll have to move the camera away.
Roger.
We can't see any Earthshine or any surface features at all in Earthshine now due to the fact that the lamp is very bright and is causing our pupils to contract.
Neil Armstrong took us through a dress rehearsal, or a typical instrument landing glide slope procedure showing how he'll do the PDI, the power defend initiate burn tomorrow, to bring Eagle, their lunar module, down to the landing site, lunar landing site 2 there. And even more important was that he was right on the money, right on the right track, but not 4 or 5 miles south, as Apollo 10 had been over that same site. Apparently, the LOI burn, the trajectory and navigation guidance work has been absolutely flawless. Armstrong appears to be all set up. Well, and as one of the men just said, looks like the LEM is ready to go down, wants to go down.
Well, it's in a way a million light years between the flight of the Wright brothers at Kitty Hawk, but it's not so very long at that when you stop to think of the actual calendar time. But of course, there have been tremendous strides. Nobody could have dreamed, no realist, I guess, could have dreamed at the time of the Wright brothers' flight that less than 70 years later, people would actually be on the surface of the moon. We have a film package for you. ABC's Don North has put it together to just trace the history of flight. Here's Don North.
Incredible as it may seem, there is only 66 years between this, the first successful aircraft to fly, and the flight of the Apollo 11 spacecraft. 66 years between the flight of Wilbur Wright and Neil Armstrong. It was in this aircraft, a frail combination of wire, wood, and cloth, on December 17, 1903, that Wilbur Wright launched on the sands at Kitty Hawk, North Carolina, and flew for 12 seconds. He covered a distance of 120 feet. A modest beginning, with few Americans realizing the significance of this achievement. The Wright brothers alone seemed to realize the significance of what they had done. Later, Orville Wright said that it was the first time in the history of the world in which a machine carrying man had raised itself by its own power, raised itself into free flight, and sailed forward on a level course without reduction of speed, and finally landed without being wrecked. A single still photographer was there to record the event. He made this photo. There were no newsmen present. Later, only one newspaper, the Norfolk, Virginia Pilot, printed the story, but they got most of the facts wrong. This film shows an early glider flight about 1902. It was through their experiments with kites and gliders that the Wright brothers developed their successful aircraft. Seen directing operations here, Wilbur Wright on the left. After 1903, the Wright brothers flew their planes in Europe for the governments of France, Germany, and Italy, and achieved worldwide attention. This is the younger Orville Wright. In 1909, they demonstrated this aircraft for the U.S. Army at Fort Myer, Virginia. With Lieutenant Frank Lahm as the passenger, Orville Wright, shown here, satisfied the Army's requirements, and Secretary of War Howard Taft awarded them a prize of $30,000. It was in Italy, before King Emmanuel, that some of the finest film of the Wright brothers' early flights was made. The European powers were very interested in developing the airplane for military purposes, And later, Orville Wright was to regret the use of the aircraft he developed in war. He said, "I feel about it as much as I do about fire. I regret its danger, but I'm glad the human race discovered it." This is a catapult launch similar to the idea of a launch from a modern aircraft carrier. There was a brave cameraman here, and notice they never flew very high, about 30 to 50 feet in those days. They weren't too sure of themselves. It was during this demonstration that the first film was made in the air. An intrepid cameraman climbed aboard beside Orville Wright, and they took off down the launch pad to take the first film shot from an airplane.
All right, they've just received a go signal from Mission Control to undock. That will take place around on the far side of the moon. So, Jules, Eagle and Columbia will now come into their own, won't they, on their own?
They're on their own, and they are pretty well committed at this point, and no one's particularly concerned about it. Eagle has checked out amazingly well, far better than it, or most lunar modules and most command modules have done on the ground, and certainly better than any of the astronauts have been able to do in the simulators. It seems to be the story which Stafford and Frank Borman and many other astronaut space commanders have told us, that when you get up there in the real vehicle, it's much easier than in all the practice sessions. It's much easier than in the hundreds of hours in altitude chambers and in test rigs on the ground. The real thing is always easier to fly. And this is the way it will be. This is the way it is now, we should say, just before undocking, which takes place on the far side of the moon, with the command module, Columbia, on the left-hand side of our frame, of course, docked to Eagle, the lunar module, both of them passing in an orbit some 60 miles over the moon. Actually, the orbit varies between 55.9 and 63 nautical miles over the moon's surface. Mike Collins alone now in the command module. Let's go to Houston for a little air-to-ground in these final moments before loss of signal. We just heard Collins talking to Capcom Charlie Duke. Let's see if we can pick them up again. There's the scene in Apollo Control in Houston. Some tenseness at the console, a quiet scene, a busy scene, as they watch and wait, as Flight Director Gene Kranz, an expert at this kind of thing, the flight director in charge of the descent, maneuver, and the lunar touchdown, has his team drilled.
Go ahead, Columbia, over. Roger, there'll be no television on the undocking. I have all available windows either full of heads or cameras, and I'm busy with other things. We concur, over. Eagle, Houston, we'd like you to select aft Omni now. It'll be good for both LOS and AOS, over. Roger, going to aft Omni.
And that was Mike Collins confirming that the live television he'd hoped to do of the undocking now cannot be done. They're switching antenna positions, which is why the signal has suddenly gotten scratchy there. As Eagle and Columbia go over the hill, as the astronauts call it, around the western side of the moon.
Apollo 11 is on the far side of the moon, and we are about 25 minutes away now from the point at which they will undock, actually separate the two spacecraft, Eagle and Columbia. And Jules Bergman is down in our mock-up of Eagle with Dick Sprague. Jules?
Frank, we're on our own Eagle, if you will, our lunar module mock-up here at ABC Space Headquarters with Grumman consulting pilot Dick Sprague, who's right now in what everybody's going to hear is the CDR station, the Spacecraft Commander Station, where Neil Armstrong will be flying Eagle down to the landing. Uptight, if you will, to that triangular window, Dick. Is that right?
Right. This will be Neil's position as he's approaching the surface.
Right. Now, what, Dick, these landing scribes of the LPD, the landing point designator, looks like an old-fashioned reticle across there on a telescopic sight on the rifle. What does Neil do with that?
Well, when he stands in the correct position, or the design eye position, aligns these scribes on the inner and outer glasses, he is then looking out at a point on the lunar surface when the computer tells him to.
Right.
And it tells him how many degrees down on that scribe line to look. He will then be looking at the point that the computer has decided to land him at.
For example, if it says 33 degrees, as it nominally does in the flight plan at low gate, that's where 500 feet above the moon's surface, That's where Neil wants it to be, and Buzz, I'm standing in Buzz Aldrin's position here. Buzz wants it to be for the actual lunar touchdown. We're going to take you through that touchdown now via animated film, picking up with the undocking that's due to take place about 25 minutes from now on the 13th revolution of Eagle and Columbia, their command module, as they pass behind the moon, the far side of the moon. As the animation shows, the two vehicles undock and pull away from one another, and Neil and Buzz are there, and Eagle, their command module, getting ready to start down. There they are, tight at the windows, as Dick Sprague showed us. The descent engine fires, that 10,500-pound DIPS engine, as you'll hear it called, in the DOI, or Descent Orbit Insertion Maneuver, which will lower their altitude from 60 miles around the moon, which is what is it now, down to the 50,000 feet where Tom Stafford and Gene Cernan in Snoopy, their lunar module on Apollo 10, got to. Then after successfully getting down to 50,000 feet, and what really is a continuous maneuver, they do the PDI, or Power Descent Initiate burn, which takes them from 50,000 feet down to the moon's surface. PDI begins 260 miles west of the landing site in the Sea of Tranquility, slowing them down all the way until they finally do the final descent vertically like a helicopter, coming down very, very slowly to what should be a smooth landing. The actual landing area, a 3.2 by 1.6 mile ellipse in the Sea of Tranquility, about 1.5 miles by about 4 miles in size. All the maps so far indicate that ellipse is smooth, that Armstrong and Aldrin should have no trouble. That's the way it'll look as they touch down on the moon's surface.
Not long ago, I talked with Neil Armstrong about, well, basically the dream that will climax with Apollo 11. You're supposed to be, and you are a pilot, not a philosopher, but you are going to be the first man to land on the moon. You must have thought well beyond the technical, purely scientific aspects of this mission. So I want to ask you really kind of an impossible question, but you're the man to give the answers. What do you think this mission will tell us about man?
If we are successfully able to execute a touchdown and return, it's going to give us an unmeasurable amount of confidence. I think that's probably the greatest result of the flight. It's going to assure those people who have been spending long hours late at night for many years in the computer labs across the street and in the simulations over in the other building and the program offices that the almost staggering technical job that they tackled is in fact possible for man to conquer. And given that confidence, we will then be in a much better position to accurately judge what we should tackle in the future. It won't be marred by a lack of understanding of what can and can't be done. It can be judged on its values.
Do you think it might help us to maybe solve some of our less exotic problems here at home, on Earth?
Well, I certainly hope that that we would take the more successful approaches that have been used in this kind of a program and find ways to apply those approaches to other problems. I don't necessarily agree that just because these people have been, in this approach have been successful that we should take their resources away from them and give them to some other people who have been less successful in their endeavors.
I get the impression you think we might be able to do both.
Well, I certainly think we can. We're a great country. We have a lot of abilities, and when we direct our efforts toward an understood goal, we usually solve the problems.
You know, I think I was wrong in putting that question to him in the way I phrased it. He is a philosopher, too, as well as a pilot. He's a young man who means what he says and says what he means. We're back in mission control now to see if we can't get some more communication.
Houston, Columbia, my distance reading 4.9. NX, 5.0 make it, and EMS 105.4, over.
Roger,
That was
copy
Mike
Columbia.
Collins.
Looks good to us, over.
We should have confirmation of the separation burn momentarily. Collins said a few seconds ago to Armstrong and Aldrin, you've got a fine-looking flying machine there, meaning he'd given
Columbia,
it a go.
Houston, we'd like you to terminate average G, over.
Roger, boom.
he said. We're waiting now to get confirmation of this separation burn.
Right, Frank. A quiet time there. The burn should just have happened.
They'll still be in visual sight of one another, though, won't they?
Right. They'll stay in visual sight for quite some time as they slowly drift apart. Collins does a small reaction control system thruster burn with Columbia's thrusters. Slowly pulls away and watches Eagle. Indeed, he can see Eagle all the way down, almost to landing. He'll see it.
This is Apollo Control. That separation maneuver was performed as scheduled, giving the command module a delta V of about 2.5 feet per second, which should give a separation to the two vehicles of about 1,100 feet at the beginning of the descent orbit insertion maneuver.
This is Frank Reynolds with Jules Bergman at ABC Space Headquarters in New York. We should tell you what Armstrong radioed to Mike Collins as he moved away in Columbia after the separation burn. He said, "You're going right down US 1, Mike." And Collins moved away, and now they are flying in tandem, so to speak, until the time comes for the DOI, or the descent orbit initiation, when they will start down in Eagle toward the surface of the moon, and Mike Collins in Columbia continues, of course, to orbit around as sort of a watchful mother hen to watch every move they make. In the event they encounter any difficulty on the way down, he does have the capability to go to a certain point, and try to rescue them. And, of course, he'll be very happy to see them come back when they crawl through that tunnel again late tomorrow afternoon.
He can get pretty low, Frank.
Well, how far down can he go? He said the other day about 10 miles, didn't he?
It varies a little bit, but Collins has apparently rehearsed the fine art of rescue in abort mode to the point where he can actually get the Columbia command module down to 20 or 25,000 feet above the moon's surface if he has to. In the unlikely event that all the lunar module's engines failed and Armstrong and Aldrin couldn't abort by themselves to get back up to the Columbia. So Collins can get down within 5 miles of the moon's surface.
Within 5 miles.
That's pretty low.
It sure is. He's at about 69 or 70 now.
Remember, I think you were there when I talked to Mike that day, and Mike's principal concern was no one is sure how high some of those craters, how low some of the craters, and how high many of the mountains are on the moon's surface. And you're coming along, it's like avoiding television towers and buildings in an airplane coming in a rainstorm. You've got to be darn sure what's going on. That's one big thing he's worried about.
Yes, like trying to land at, say, one of New York's airports without knowing very much about how the buildings were around New York. Well, we thought we'd have some heavy thinkers here now for a change, and take a small break while Jules and I get a moment of rest. And we're going to have some thoughts by three very important people about why we should be going to the moon. Here's Bill Moyers, the editor of Newsday, Marshall McLuhan, the philosopher of communications technology, and Ian McCard, a regional planner, amateur ecologist, author of Design with Nature. ABC's Howard K. Smith asked Mr. McCard about the motives that send Earthmen to the moon.
I would give all honor to the astronauts and NASA for this, phenomenal adventure. But it seems to me there are two motives here, one of which is good and the other, I think, quite bad. The good motive is the increase in man's knowledge. The bad motive, I think, is the motivation of conquest. And I think our attitude to nature has been, throughout the whole Western tradition, one of conquest. We talk about conquering Mount Everest and conquering the moon and conquering space. And we have, traditionally, this whole culture, thick, low-browed, dull-witted, territorial, laying bludgeoning strokes across, the world-life body, destroying and singing paeans of self-praise as we go. And I think there is an aspect of this, you see, in the conquest of space. And it is really based, it's the same witless...
It's metaphoric, so when you say the conquest of space, you mean it's a metaphor.
Oh, I think it's not a metaphor. I really believe the Western tradition does believe that man has a moral duty to conquer nature. I mean, he is exclusively divine, or so the Genesis tells him, given dominion over life and non-life, enjoined to subdue the earth. And by God, the whole Western tradition, Judaic and Christian, has tried to give the best evidence of this dominion and subjugation that it possibly can. And the conquest of space is just one of the spin-offs of this arrogant, anthropocentric, witless, clottish man who insists on subjugating the earth and all creatures.
I don't look at it that way. I think man is essentially an explorer. He's always reached out into the unknown, and Mr. McLuhan said earlier that if something can be done, it will be done, and man is going to determine that he can do this. I think it is not a greedy, avaricious reach for something that he would like to control as much as it is for something about which he would like to know more. And I think as long as there is something unknown, man will be trying to reach for it. What I've learned from all of this is that man also, as a political animal, has the capacity to organize himself and his peers in such a way to attain a goal that a decade ago seemed to be impossible and seemed to be forbidding. And what I hope that we can do from this is to see the difference that exists between what we've done in space and what we yet have to do on Earth, and organize ourselves to achieve the goals which will affect the lives of billions of people on the Earth, as well as the lives that will be affected of a few men who will make it into space.
Bill, you were in a high place in government at a time when this program was launched. Do you think that it's been a wasted effort, that it has been a perversion of resources and skills?
No, I don't, for this reason. We were not doing very much in the social and domestic field in the late 1950s when we were not searching for the moon or reaching into space. We have done more on Earth since we have been doing more in space than we ever did in the decade before. That's a syllogism, perhaps, which proves nothing except the fact that this nation is so wealthy and so rich that it really has the capacity to do what it will organize itself to do and what it establishes as its priorities.
But, Mr. Moyer, have you considered that the Russians, who have never had a 19th century, who have many less resources than we, have also accomplished more or less the same goals in space?
But at a greater price. You see, their GNP is such that they could not carry on a consumer revolution at the same time we have been doing that.
All right.
And so they had to give up something. I don't think we have to give up something. I think we do, because it is so much easier to reach a goal that has few political obstacles in front of it than it is to try to do something about some of these problems which have political
It's a kind of luxury for us to play with these things, whereas it's life and death for the Russians.
No, it's not life and death with them. They made it a matter of life and death.
On the other hand,
the allocation of their very meager resources.
On the other hand, with Sputnik, they created a very witty pun, which was carried out visually. Little fellow traveler. They put this little fellow traveler as an environment around the planet, a planet that was terrified of fellow travelers, and they put a little one out there to reassure us that it was friendly.
They didn't create the pun, Mr. McLuhan, you did.
Well, the word Sputnik means little fellow traveler in Russian. And it was done at the time when fellow travelers were rather a menace.
But they did it for a very esoteric group of men of whom you are the paramount chief.
No, I'm very flattered, but I heard that from a great many other people. I didn't probe into the etymologies of the word. But it is, I think it's worth considering, since they do have a sense of humor, what the Russians had in mind in the complementarity of this current effort.
Yes. I think at least in the beginning, Mr. Smith, they had a military purpose behind their space effort. And I think this is one of the reasons that our leaders at that particular time, particularly in 1960 and 61, were motivated out of a sense of reaction even to some extent, fear, which has been translated into the prestigious reach for to be first in space. But I think they really had serious military motives behind their...
Are there, when you say serious military motives, I shouldn't think military motives half as serious as many others, including educational. But when you attach the word serious to military, I don't.
It can be attached to almost any word.
Well, there are many military efforts that we're making that are not serious in the sense of irrelevant.
You don't think of you don't think of Apollo 11 as having any relation to our own military interests?
By all means, the present head of the Apollo program, who is a general, indicated today that he will be leaving the Apollo program a few days after the flight in order to go back to the Pentagon to apply the techniques he's learned in the Apollo program to our defense effort. So I think, to go back to one of your first questions for 1 second, you said, what is the value of this? Well, there are many esoteric values that are still to be realized. There are many long-range projected values that the millennia will realize, but the immediate value is military. Let's face that. The practical, significant application of our space effort, if it has any pragmatic value whatsoever, is basically military.
Let's ask ourselves in long-term projects about the meteorological possibilities of the conquest of moon space.
You could ask him.
Can we consider the possibility of space platforms that might serve the control of climatic conditions eventually on Earth?
I haven't a finished idea. I'm the wrong man to ask about this. I do know that satellites orbiting the Earth, of course, can have an enormous utility. They now have elaborate sensors. The Interior Department is going to send up another satellite. Is it not Aeolus? And this beautiful creature will be able to monitor the Earth continuously, and we'll be able to observe things as delicate as the amount of carbon dioxide or the productive fertility or health of crops, sedimentation in rivers and so on. The whole dynamism of natural processes may be continuously monitored. This material could be digitized into computers immediately, and that material can be used by people like me to make regional planning decisions. And this is enormous social utility.
A historical moment, a historical point here. Back in the early days of the space effort, and even into the acceleration of the Apollo program in the early days of 64 and 65, the men who brought to the president, to the White House, the projections, the facts, the research, the figures, were very realistic about the immediate practical effects of this whole program. As far as interplanetary travel is concerned, it will remain for generations to come a very esoteric feasibility, for the very simple reason that it will be a long time and take many billions of dollars before we can develop the kinds of programs that will make interplanetary travel, vehicles that will make interplanetary travel available to more than 3 or 4 men at a time. To go to the Mars, for example, is a 2.5-year round trip.
Mr. Moyer, you are working on the assumption that the present forms of fuel and hardware are indispensable for such travel.
One of the reasons they want the specimens from the moon is to see to what extent minerals exist in the moon and the quantities of moon material that can be used for space fuel. They may not exist, but that's one of the purposes.
It's not at all likely that we're going to continue our present forms of fuel for earthly transport, let alone interplanetary transport. We can tell by saturation and pollution that we're reaching a terminus in many areas of use of materials. And at any time, like the automobile, we know the automobile is, we don't know why, we know it's finished because technologically it has become such an incredible nuisance. But by the time any form of human activity becomes surfeiting and sheer pollution, then you know a big change is handy. The hidden change created by moonshot is the creation of a totally new environment for human knowledge.
Well, thank you very much indeed.
Let's go to Mission Control in Houston.
Columbia, Houston, over.
Houston, Columbia, reading you loud and clear. How many?
Right, bye, Mike. How did it go, over?
Listen, babe, everything's going just swimmingly. Beautiful.
Great. We're standing by for Eagle.
Mike Collins saying the descent order burn and fire.
We copy out. And Columbia, Houston, we expect to lose your high gain sometime during the power descent, over.
Columbia, roger. You don't much care, do you?
No, sir.
Okay.
We have acquisition of signal from the LEM.
And we're having some antenna problems with Eagle. Power control not yet getting good quality. At this point, Eagle, as you heard Doug Ward in Mission Control saying, is descending through 12 and a half miles over the moon, nearly at the lowest point.
Houston, we have you now. Do you read over?
Loud and clear.
Roger, we see your Verb 47.
That's Buzz Aldrin talking to Charlie Duke, the Capcom.
Hey, I don't know what the problem was there. It just started oscillating around in yaw. According to the needle, we're picking up a little oscillation right now, as a matter of fact.
Roger, we'll work on it.
Aldrin is referring to the LEM steerable antenna. That comment about the oscillations.
Good, clear communication now.
check was right on time.
Roger.
Armstrong confirming he's finished his checklist.
Did you copy the the sun check, Charlie?
That's affirmative. We did, Buzz. Out.
And Eagle now beginning to swing around the eastern side of the moon and back in touch with the Earth. Coming up on landing side 1, above which they will do the power descent burn to land themselves 260 miles further east on landing site 2.
Eagle, Houston, the AG's initialization looks good to us, over.
Roger.
Confirming the abort guidance system, and the test worked fine. Collins in the command module 50 miles overhead and slightly ahead of the Eagle.
Gene Kranz getting a go, no-go for descent.
Eagle, Houston, if you read your go for power descent, over.
Eagle, this is Columbia. They just gave you a go for power descent.
Columbia, Houston, we've lost him on the high gain again. Would you please, we recommend he yaw right 10 degrees and reacquire.
Eagle, this is Columbia. Your go for PDI, and they recommend you yaw right 10 degrees and try the high gain again. Bill, 10%.
That was Buzz Aldrin telling us he was up to 10% throttle on the PDI burn before the radio communications cut out again. The 10% throttle meaning it's going okay as you descend through 46,000 feet, the last count. And then they had trouble with that LEM steerable antenna again. But they're headed downward.
Columbia, Houston, we've lost him. Tell him to go aft on me, over.
Mike. Hey, Neil. I'll leave it in flu. Relay to us. See if they got me now. I got good signal strength in flu. Yeah, you should have me now, Houston.
Eagle, we got you now. It's looking good, over.
Eagle, that looks good.
Eagle, Houston, everything's looking good here, over.
Roger, copy.
Eagle Houston, after yaw around, angles, S-band pitch, -9er, yaw, +18.
Copy. Mags and things agree very closely.
Roger.
Bait on. Altitude's a little high. Two minutes, 20 seconds, everything looking good. We show altitude about 47,000 feet.
Right on the money.
Yeah. Bill? Houston, I'm getting a little fluctuation in the AC voltage now.
Roger.
Just the meter maybe, huh?
Stand by. It's looking good to us. You're still looking good at coming up 3 minutes.
Pretty deep. That's real good. Hold it. Start on.
Our position check downrange shows to be a little off.
Roger, copy.
Ag is going about 2 feet per second greater rate.
That was Armstrong saying we're a little long downrange on position. You'll have to correct slightly. They should be through 45,000 feet now.
I think it's going to stop.
There's Aldrin again.
Eagle, Houston, you're a go to continue.
At 4 minutes.
Roger, you're a go to continue power descent. You're a go to continue power descent.
Roger. Altitude 40,000.
And Eagle, Houston, we got data dropouts. You're still looking good.
They should be coming up on landing radar acquisition now. The ground beneath them telling them exactly how high they are.
Good lock on.
That's it.
They got it.
Radar lock.
Altitude lights out. LH is minus 2,900.
Roger, we copy.
At the Earth, right out our front window. Houston, you're looking at our Delta H.
That's affirmative.
Program alarm.
It's looking good to us, over.
1202. 1202. Good radar data. Altitude now 33,500 feet. Give us a reading on the 1202 program alarm.
Roger, we got you. We're going at alarm.
Roger, 330.
6 plus 25, throttle down. 6 plus 25, throttle down.
Roger, copy. 6 plus 25. We're still go, altitude 27,000 feet. Same alarm, and it appears to come up when we have a 1668 up.
Roger, copy.
Eagle should be slow to 1,200 miles an hour now.
Eagle, Houston, we'll monitor your Delta H.
Beautifully.
Delta H
looks good now.
Roger, Delta H is looking good to us. Throttle down on time. Roger, copy, throttle down. Throttle's down. Set him in the simulator. Right.
About 60 miles from their landing site.
Heights and things look real close.
Altitude now 21,000 feet, still looking very good.
And they should be down to 800 miles an hour forward speed, about 102 miles an hour vertical speed.
Velocity down now to 1,200 feet per second.
You're looking great to us, Eagle. Okay, I'm still on flu, so we may tend to lose as we gradually pitch over. Let me try auto again now, see what happens. Roger. Okay, looks like it's holding. Roger, we got good data.
They're following their flight plan almost unbelievably closely to this point.
7 minutes, 30 seconds into the burn. Altitude 16,300 feet.
Eagle, Houston, it's descent to fuel to monitor, over. 22.
Altitude 13,005.
Final radar check coming up.
Velocity 9,100 feet per second.
Made it, switch over time, please, Houston. Roger, stand by. You're looking great at 8 minutes.
Correction on that velocity, now reading 760 feet per second.
It's the P-64. Good. Roger.
Fido says we're go, altitude 9,200 feet.
830, you're looking great.
Descent rate 129 feet per second.
We copy.
Or about 80 miles an hour. And they're down to 300 miles an hour forward speed, coming up on high gate, the next critical point.
Eagle, you're looking great. Coming up 9 minutes.
We're now in the approach phase, everything looking good. Altitude 5,200 feet.
Manual attitude control is good. Roger, copy.
Altitude 4,200.
Houston, you're a go for landing, over. Roger, understand. Go for landing. 3,000 feet. Copy. Alarm. 1201. 1201. Roger, 1201 alarm. We're go. Same type. We're go. 2,000 feet. 2,000 feet. Into the ag. 47 degrees. Roger. 37 degrees. Eagle looking great. Your go.
Altitude 1,600. 1,400 feet, still looking very good.
Roger, 1202, we copy it. 35 degrees. 35 degrees, 750, coming down to 23. 700 feet, 21 down, 33 degrees. 100 feet, down at 19. 540 feet, down at 30, down at 15. And 400 feet, down at 9. Gate forward. 10 and 50 feet, down at 4. 30, half down. They're pegged on horizontal velocity. 300 feet down, 3.5. 47 forward. Put up. On 1.5 down. 70. That big shadow up there. 50 down at 2.5. 19 forward. Altitude, velocity, light. 3.5 down. 220 feet. 13 forward. 11 forward, coming down nicely. 200 feet. 4.5 down. 5.5 down. 160 feet. 6.5 down. 5.5 down. forward. Good. And 20 feet. 100 feet, 3.5 down, 9 forward. 5%. How many feet? 75 feet. Car's looking good, down a half. 6 forward. 60 seconds. Lights on. 6. Down 2.5. Forward. Forward. That's 40 feet, down 2.5. Picking up some dust. 30 feet, 2.5 down. Straight shadow. 4 forward. 4 forward. Drift into the right a little. 6. Down a half. 30 seconds. Forward. Just. Okay. Contact light. Okay, engine stop. ACA at a descent. Host control, both auto, descent engine command override off. Engine arm off. 413 is in. We copy you down, Eagle.
Griffin, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
Thank you.
You're looking good here.
Okay, we're going to be busy for a minute.
After Armand, take care of the defense. I'll get the stuff prepared. Very smooth touchdown. That's good. Looks like we're mending the oxidizer now. Roger, Eagle, and you are stay for T1. Over. Eagle, you are stay for T1.
Roger.
And we
Sam, stay for T1.
Roger, and we see you venting the ox.
Roger. Break it.
Is that right?
Armstrong and Aldrin have made it. And everyone wondered what Neil Armstrong's first words would be. This is Tranquility Base. Tranquility Base.
Copy, now 60, now 43. Roger, we have it. Yes, sir. I read Columbia on the high gain. Roger, we rigged you 5 by Columbia. He has landed Tranquility Base. Eagle is at Tranquility, over. Yeah, I heard the whole thing. Well, good show.
Collins and the Columbia Command Module.
Fantastic.
Stop reset.
There was never any doubt about what Armstrong was going to do. He had a low fuel light on there, his fuel warning light, and he was very near not being able to do it.
The next major stay, no stay, will be for the T2 event. That is at 21 minutes, 26 seconds after initiation of powered descent.
Columbia went up telemetry command reset to reacquire on the high gain.
Copy out.
And there seems to be an absence of drama and emotion in Armstrong and Aldrin's voice. They're busy checking out the spacecraft to be sure they can get off the moon in a hurry if anything goes wrong. And nothing has gone wrong, though. Every sign, Frank, seems to indicate it's okay. And when he was at 40 feet there, it said some dust being kicked up by the engine.
Yes. You must have set that thing.
We have an unofficial time for that touchdown of 102 hours, 45 minutes, 42 seconds, and we will update that.
It was so so unerring, it was almost unbelievable.
Eagle, Houston, you loaded R2 wrong. We want 10254.
Roger.
The descent took them just a little bit longer than had been calculated, but outside of that, he followed the descent flight plan second by second, as far as we could tell.
He was able to make the adjustment himself. He was actually flying it down with Buzz calling out all those numbers to him.
Right. Those last numbers we heard were the forward speed and the descent speed of Eagle. Now at Tranquility Base. 2 Americans on another planet. Still ahead, if all these checks go right, of course, about 10 hours from now, unless Neil decides to do it sooner, that 2-hour and 40-minute spacewalk. Another tough bit of action, but not nearly the crunch. Moonwalk. Yeah. Not nearly the crunch, as you put it, that landing was. Yeah. The next big crunch, I think, is the ascent.
Sure. These men breed a confidence in the rest of us, though, by their own actions.
Houston, that may have seemed like a very long final phase. The auto-targeting was taking us right into a football field-sized crater with a large number of big boulders and rocks for about 1 or 2 crater diameters around it. And it required us going in P-66 and flying manually over the rock field to find a reasonably good area.
Roger, we copy. It was beautiful from here. Tranquility, over.
Armstrong was right. He said he'd have to do it by manual control.
It's a good thing he did, too, because
I'll
automatically...
get to the details of what's around here, but it looks like a collection of just about every variety of shape, angularity, granularity, but every variety of rock you could find. The color is, well, it varies pretty much depending on how you're looking relative to the zero phase point. There doesn't appear to be too much of a general color at all. However, it looks as though some of the rocks and boulders, of which there are quite a few in the near area, looks as though they're going to have some interesting colors to them, over.
Roger, copy. Sounds good to us, Tranquility. We'll let you press on through the simulated countdown, and we'll talk to you later, over.
Roger. Okay, this 160 is just like the airplane.
Roger, Tranquility. Be advised there are lots of smiling faces in this room and all over the world, over.
There are 2 of them up here.
Roger, it was a beautiful job, you guys.
And don't forget one in the command module.
Roger.
Mike Collins. And Capcom Charlie Duke telling him to get back to that simulated countdown.
So that last remark from Mike Collins at an altitude of 60 miles. The comments on the landing, on the manual takeover, came from Neil Armstrong. Buzz Aldrin followed that with a description of the lunar surface and the rocks and boulders that they are able to see out the window of the LEM.
One last engine remaining to be tried. 96 engines aboard that Saturn V, the command module, the lunar module, and one big one remaining untried, the ascent engine for liftoff tomorrow afternoon to rejoin Columbia, the mothership, and Mike Collins, orbiting the moon 60 miles overhead, Tranquility Base. A new word, a new place in the solar system.
How did the country react? Well, let's find out about the capital anyway, and let's go to Washington now to see just what happened there. ABC's Sam Donaldson.
Okay, I'll wait.
Man on the moon. These people are on the Connecticut Avenue sidewalk outside our ABC News Bureau across from the Mayflower Hotel. We have just seen the confirmation that the lunar landing is a successful one, that man is, in fact, on the moon. ABC News has been providing this service all weekend, but nowhere has there been as much excitement as there has been just for the last few minutes
as we have gotten confirmation of the moon landing. And let's find out what people think. What's your name?
My name is Hiram Vega.
How has this affected you?
Well, we are from New York City. We are Puerto Rican, and then we was going to...
Yeah, but tell me how you think the moon landing has affected you.
Well, I'm very surprised about this. This is wonderful. It's something unbelievable.
You think it would ever happen?
No, I believe this will be something really... they're going to be very successful.
Thank you very much. Madam, tell me what you feel at this moment.
I think it's one of the greatest achievements in the aeronautical world.
When you were a little girl, did you ever think you'd see men on the moon?
Well, I used to tell people to go to the moon. I don't know. I think, yes, I believe I would.
Have you ever had an experience that has affected you quite this way?
Well, not in this, no, but in some cases, yes.
Thank you very much.
Thank
What's
you.
your name, sir?
I'm Earl Boyd Pierce, a lawyer from Muskogee, Oklahoma.
What do you think about
I've
this?
witnessed the landing on the moon. I think it's one of the greatest feats of all time.
Does it amaze you that it's taken
It
place?
not only amazes me, but I'm certain that it amazes everybody in this country.
Do you think it's worth it?
It's certainly worth it, and it's the greatest accomplishment of the people of this nation. There isn't a question about that.
Thank you very much.
Yes.
What is your name, sir?
Frank Stanley.
What do you think about this moon landing?
Well, it's the beginning of a new frontier, the gateway to Mars.
What do you think about the astronauts, Armstrong and Aldrin?
A great achievement.
Do you think it took great courage to do what they've done?
It took teamwork. Teamwork was all.
Are you proud of the fact that we've landed on the moon?
Very proud.
Thank you very much. Tell us your name
Kathy Walthouse.
and your feeling about seeing two men on the moon.
Exciting. Everybody's always excited when you go to a new place, when you have a new frontier, when you have hope that perhaps as we advance scientifically to the place where we can go to the moon, we don't have to advance scientifically to have test tube babies.
Well, let me ask you a question which may seem irrelevant, but we've heard a great deal about the romance having gone out of the moon now, all of the romantic songs. Do you think it's going to be the same for you?
No. I'd like to go.
Well, in what ways has it changed?
Because of all of the things that have gone on before in space, perhaps we assume that we can always make it. We don't think anything can go wrong. For example...
Well, I'm actually speaking about earthly romance. Two lovers who look at the moon, you see, and spoon by it, as an old song used to go. Is it going to change for them?
I doubt it. I don't think human beings change that much no matter where they are.
The moon will still be a nice object.
A nice object to watch, and it'll be a nice object to live on, perhaps.
Thank you very much.
We're told now that President Nixon watched the touchdown on the moon on a portable color television set in the executive office building just across the street from the White House. Immediately after the landing, he called the Secretary of State Rogers at home. He said it is the greatest moment of our time. The success of this operation will be immensely favorable and will bring the people of the world closer together. That seemed to be what Mrs. Armstrong, the astronaut's mother, was saying shortly after the touchdown. The president went on to say these procedures are the greatest steps in the history of mankind, and as Dr. Payne may have reported just a moment ago, he told Dr. Payne later on the same modern technology that got men to the moon will get them back. Jules?
Frank, we're going to attempt to give our audience an idea topographically on the moon's surface of exactly where Armstrong and Aldrin did land in Eagle at Tranquility Base. We're going to use our telestrator, this amazing electronic device, to show them how what actually happened in the landing process. They were due to land, if the camera can pan just a little bit left on this lunar topographic chart. A little more left now till we pick up the ellipse that was the original target. More left, slightly more left. There we are. Now, we're electronically implanting on the target card, these were the actual descent charts used by Armstrong and Aldrin, the original ellipse. Well, we were too low somehow. We'll try again. That was the original ellipse there. And what happened as Apollo 11, as the Eagle swept in her approach card over the lunar equator, Armstrong looked ahead and saw that this area had this football-sized field, crater field, full of boulders, and in effect overshot it. We're a little off on our lines here. Overshot it and came down 4 miles to the west in a new area right about here, just south of the lunar equator, in a perfect landing procedure. And the amazing thing was that he needed every bit of his fuel reserve to do the maneuver with.
Well, Jules,
the telestrator is an amazing electronic device, Frank, that enables us to electronically write on a television set and directly to home audiences.
Yes, well, the thing that I wonder about, though, this football field full of rocks, had that been charted? Did they know in advance? Was that in the actual landing site area?
That was the precise actual landing site area, Frank, that was on the lunar orbiter chart. Yeah. Now, I'll go over that again for a second. The amazing thing, and I still don't quite understand all of this, is that our pictures were formed from lunar orbiter pictures, which were taken rather high over the moon's surface, and apparently missed this area. Lunar orbiter's pictures were supposed to be down to 1 meter or 3-foot resolution in many cases. Remember, I mentioned earlier that orbiter was capable of 1 meter, 3-foot resolution, just about like that. And indeed, the scientists had spotted 6,000 craters, large, small, medium, minute craters in this area. But apparently the football field-sized crater was completely missed. So it was old-fashioned pilot judgment by Neil Armstrong. Neil Armstrong, the flying kid who started at 15, who came in, saw the problem, and landed long. Used up half of his remaining fuel reserve and came darn close to having to abort, but did a beautiful job.
You know, none of the astronauts involved in this historic event, this very dangerous operation, is due to become a millionaire out of it. As a matter of fact, I think Buzz Aldrin said not long ago, when somebody said to him, what are you going to do after the flight? He said, well, I'm not going to become a millionaire. Money doesn't seem terribly important to them in that sense, and perhaps it's a good thing that they have other motivations. Neil Armstrong gets about $30,000 a year. He is a civilian, of course. As a government employee, at his grade, he gets about $30,000. Colonel Aldrin gets about $18,000, I think, and Michael Collins, who was a lieutenant colonel, gets around $17,000 or so with all the flight pay and so forth. There is somebody who is going to make more from their landing than they will make in a year. Well, not quite more than what Neil Armstrong will make in a year. There's a 26-year-old Englishman. We told you about him some time ago. He made a bet 5 years ago that man would land on the moon before 1971. And now he stands to win $24,000. David Threlfall is the man's name. He's a science fiction buff. And he took odds of 1,000 to 1 from one of England's largest bookmakers. He said he was just playing a hunch bet. And I suppose 5 years ago, 1,000 to 1, well, I don't know, Jules. I think that the bookmakers kind of deserve to suffer their fate. 5 years ago, it didn't seem that it would be 1,000 to 1 shot, did it?
Maybe 100 to 1. 1,000 to 1 seems pretty outlandish to me.
Nobody was giving me any odds of that kind 5 years ago.
You weren't in the right places, Frank.
Well, anyway, we have David Threlfall in London, and I guess he's collected his check, and let's go to London and see the man.
David Threlfall is a young Englishman. In the normal course of things, nobody would ever hear much about him. But 5 years ago, he bet 10 pounds, $24, that somebody from someplace on Earth would touch on the moon by 1971. William Hill, a bookie here in London, took the bet at odds of 1,000 to 1. Tonight, with a touchdown on the moon, David Threlfall collects $24,000. Now, when you placed your bet with William Hill, you didn't say that it will be an American on the moon by 1970.
No, anyone, Chinese, Japanese, a man, woman, or child from any nation on Earth. That was the wording of the bet.
You made it that specific, man, woman, or child from any nation on Earth.
I wanted to say woman or child because I wasn't sure of the payload you could carry. And I thought you might be tight for weight, so I tried to cover every option and tried to make it as unambiguous as possible.
Well, 5 years ago, it was a bet. Obviously, it was a bet because William Hill was quoting odds of 1,000 to 1. When did you begin to feel that, by heaven, you're going to win this bet?
I think it was in 1966 when they proved that they could do a soft landing, that it wasn't cream cheese or a mile of dust. I think that was the only factor. There was some doubt when the three Americans lost their lives and there was a delay in the program. But once they got over that, then I was always certain.
The British are not getting much glory out of this landing on the moon, but here in London there is a little pride that apparently an Englishman at least is going to get the most money out of it. This is Bill Buttell, ABC News, London.
Oh, here comes Mrs. Armstrong out of her home. Let's go to Texas.
It's a bit easier now.
Yes. Yes and no.
How did it feel at the moment of touchdown?
Oh, I was terribly excited. It's a marvelous thing that we have successfully managed to land safely on the moon.
What was the reaction of the children, the two boys?
We were very excited.
Neil had a slight problem with Gemini 8 with a malfunctioning thruster. Perhaps you can move just a moment. Your light is just behind you, just a little bit to the left or right. Had a problem with a malfunctioning thruster. There were no problems this time. It must have been quite a difference as you were following along.
Yes, it was.
Is Neil carrying anything for you to the moon?
Yes, but that's private.
You're not going to tell us? Animal or vegetable or mineral? Was there any special incantation today, any special prayer, something that you can share with us that you had as those moments near touchdown came?
No, we have said our prayers all along. From the time they had separation, we knew it was go all the way, and I didn't say any extra special prayers at that time. My faith is with me always.
I'm told that Neil was a very poor history student as a boy. Now he's made history. Are you going to encourage the two boys to become astronauts?
No, I will encourage the boys to do whatever they would like to do.
What do you think they'd like to do?
That's completely up to them.
Miss Armstrong, can you describe what you were doing at the moment of touchdown?
I was sitting on the bed in my room, and I was watching the map minute by minute and following all the craters that they were going over, and doing the best I could to follow them all the way.
Your husband had to do a little bit of flying. Is that suspenseful for you?
No, sir.
And there was a little bit of a problem with communications for a while. Was that a tense moment?
No.
What is that pin that you've got? Maybe you can describe that. It says JA, and it's a model of the lunar module.
Well, that's a model pin, which is a model of the LEM with my initials on it, which I
Jan Armstrong.
very highly.
Where did you get this, Armstrong? Yeah. Where did it come from?
It was a gift.
From Neil? Your husband?
Can you tell us what you'll be doing tonight and from now on?
I will be continuing to follow the flight and listening to their descriptions on the moon. Probably reading them in the mission reports again and over and over and over again. I think it's fantastic, and I'm just about as excited as you all are.
Are you following?
Well, I have here a reservation for a flight to the moon as a paying passenger, although I haven't paid anybody anything for this card. It's a card issued by Pan American World Airways to people who apply for seats on the first flight, or the first flight they can get. And you know, more than 17,000 persons already have applied to Pan Am. Pan Am isn't making any promises about this, but the airline does say quite soberly that commercial aviation is never very far behind scientific pioneering. As Jules Verne said 100 years ago, an American sees no real difficulty in anything. And whole families have reserved space on the first flights, despite the estimated round-trip fare of $28,000 per person. ABC News talked to several happy applicants at the Pan Am ticket office in New York.
What do you expect to see on the moon, Andrew?
Craters.
Craters, and what else?
Big holes.
Well, what will be most interesting that you see from the moon?
Craters.
My main desire in life would be to be an astronaut, but I've been a little bit more practical. And I heard about the Pan Am waiting list for the moon, and I decided that would be the next best thing to being an astronaut.
So many people nowadays are concerned with weight watching and how to go on diets. Might be nice just to go to the moon and sense that feel of weightlessness without all the effort.
If I ever go to the moon, I think it'll be very fun. I just hope to go very, very soon, and I hope I'm not really that old.
The moon, I'm afraid, would be very sandy and not very pretty to look at, and all these big crater holes and everything else. But I'm just wondering, do you need oxygen to go to the moon? Because I need very little of it. I would be a very good passenger, I think, to go to the moon, because I need very little sleep, need no medication, and I need little oxygen, and I can stay on a liquid diet for weeks. And if we come down and splash down in the ocean, I can float by the hour. So I think it wouldn't be a bad idea to go to the moon, even at my age.
Be advised now that the men are going to walk on the moon tonight, so better not plan to be anywhere very far from a television set at approximately 8 o'clock Central Daylight Time, 9 o'clock in the east, and that is when we now expect that they will open the hatch on the spacecraft and Neil Armstrong will come down and we will have this historic walk on the moon. Well, this is, we are covering here, of course, the event of, some might say, of the century. But other things have been happening in the world today, many other things. And in order to bring you up to date on what has been taking place while the rest of us have been watching the progress of the moonshot, here is ABC's Peter Jennings. Peter?
There was other news today. The Middle East conflict heated up with an air fight between Israeli and Egyptian planes over the Suez Canal. Egypt says it shot down 17 of the Israeli jets, but Israel admits to losing only 2. And in return, reports shooting down 5 of the Egyptian planes. The Israeli report adds that the 2 pilots of their downed planes bailed out and landed safely in home territory. About the only fact on which both sides agree is that Israel started the fighting this time. And a spokesman in Tel Aviv says Israeli planes attacked Egyptian positions on the western side of the Suez Canal because of what he called Egypt's total disregard for the ceasefire line. A spokesman also said it was the first time the Israeli Air Force had attacked since the 1967 war. It is the Air Force on which Israel depends primarily for its defense. A report on that tonight from ABC's Russell Jones in Israel.
The Israeli Air Force, the spearhead of the Israeli attack, is getting an infusion of new blood. A class of air cadets is being inducted into active service. The Israeli armed forces are the nation's elite, and the Air Force is the cream of the cream. These young men are the survivors of training so rigorous that 80 to 90% of the cadets fail to pass. They are greeted by General the Minister of Defense and the hero of both the 1956 and the 1967 wars. The highlight of the show are aerobatics by Fuga trainers, one of the few planes the Israelis permit anyone to get a close look at. The French-made Mirages, Israel's best warplanes, flashed by so fast they were difficult to see. The demonstration of firepower lasted 2 minutes and included napalm, something the Israelis only recently admit they have used. The troop-carrying helicopters are the same type the Israelis are reported to have used on raids deep into Egypt, but the security-conscious Israelis have never even admitted they used any kind of helicopter on the sorties. Much publicized but little seen except by the enemy, this is one of the few occasions the Israeli Air Force puts itself on display. Russell Jones, ABC News, on an Israeli air base.
There is still, of course, a war in Vietnam. Despite rocket and mortar attacks in the last 24 hours, the situation there is considered to be a continuation of what military spokesmen call a lull. And preparations are going ahead for the withdrawal of the balance of the 25,000 American troops that are to be out of Vietnam by the end of August. But turning control back to the South Vietnamese is not a simple matter, as ABC's Ted Koppel explains tonight in this report from a Special Forces camp in the Mekong Delta.
This Special Forces camp faces as much danger from within as from outside its perimeter. There are 6 companies of Vietnamese and Cambodians assigned to the camp with their families. There are also 12 U.S. Special Forces advisors. Several months ago, counterintelligence uncovered a plot to take the camp from inside. The U.S. Special Forces commander requested that a lie detector team be flown in. The next morning, 55 of the Vietnamese attached to the camp were missing and were never seen again. Counterintelligence has since reported another plan to take the camp from inside. This one is expected to coincide with a military assault from outside. Special Forces has pinpointed several suspects. High on the list are 2 girls who work in the team house kitchen, the father of one of the girls who is camp carpenter, and the uncle of the second girl who is camp mason. Far from being unusual, this kind of situation exists in most U.S. Special Forces camps. The American commander in this camp, Captain Brian McDonald, wants to gather more information before he makes his move. And so the Americans mount a special guard every night to keep an eye on their allies. This is Ted Koppel, ABC News, in the Special Forces camp at Ba Swai.
It is a case of watchful waiting in Paris, too, where the Vietnam peace talks appear to have entered a new lull of their own. The North Vietnamese have turned down the latest South Vietnamese proposals on elections, but, of course, haven't come up with anything new on their part. Allied sources indicate nothing much can be expected to happen in Paris until after President Nixon's forthcoming Asian trip. But perhaps there may be developments in Washington after General Wheeler, the chairman of the Joint Chief of Staff, reports to President Nixon on his just-completed tour of Vietnam. That report tonight from ABC's Sam Donaldson.
General Wheeler is expected to return from South Vietnam on Tuesday, bringing with him his first-hand impression of what meaning, if any, can be read into the current lull in the ground fighting. If it's read as a deliberate communist peace move, the president may be under great pressure to reciprocate, possibly by announcing a heavier second-step American troop withdrawal. While the White House mulls that over, the Senate will continue debate on the ABM, with no final vote anytime soon. Senator Mansfield thinks the vote may not come until September. But with the delicate Senate strength apparently shifted in favor of the president's safeguard ABM proposal. On taxes, Mansfield and the Democratic leadership remain firmly opposed to Senate consideration of the House-passed surtax extension bill until tax reform is coupled to it. The Republicans will spend the week trying to argue Mansfield out of this position by saying that each day's delay imperils the economy. But all this activity will have to go on without the city's chief resident. President Nixon attends the All-Star game at Kennedy Stadium Tuesday evening, then leaves immediately on his round-the-world trip. Sam Donaldson, ABC News, Washington.
Those Soviet warships that steamed down the U.S. coast and parked for a while off Cape Kennedy arrived today in Havana Harbor. Thousands of Cubans lined the shore, many of them waving Soviet flags. A hearing for Senator Edward Kennedy will be held in Edgartown, Massachusetts tomorrow. The senator may be charged after that hearing with leaving the scene of an accident. A car he was driving, as you'll remember, plunged off a bridge around midnight on Friday, killing a woman passenger. Senator Kennedy, reportedly in a state of shock, did not report the accident until some hours later. He said he had tried to rescue the woman but failed. The county clerk, tomorrow, must decide if the evidence warrants serving a summons on Senator Kennedy. In Washington, Democratic leader Mike Mansfield said it could have happened to anyone. Mr. Kennedy has my full confidence. Explorer Thor Heyerdahl is scheduled to arrive at the Caribbean island of Barbados tomorrow. He was forced to give up his planned voyage in a papyrus boat from Africa to Central America. Sharks prevented the crew from repairing the storm-damaged vessel, so the sailors went aboard an accompanying yacht. Heyerdahl, in a message today to U Thant at the United Nations, said that space-age man has too much in common to be separated by political blocks or racial barriers. In Major League Baseball today, the National League, St. Louis at Pittsburgh, and the Houston doubleheader at Cincinnati were canceled by rain. The Eastern Division leader Chicago beat Philadelphia 1-0 in the opening of a twin bill. And Montreal beat the New York Mets 3-2 in the first of their two games. Atlanta trumped San Diego 10-0. In the American League, it was Kansas City 8, Chicago 6 in their opener. Detroit beat Cleveland 3-2 in their first game. The New York Yankees beat Washington 3-2 in 11 innings. It was Boston 6 and Baltimore 5. California and Oakland are playing on the West Coast, as are Minneapolis and Seattle. That is the news of this planet this evening. Coming up, of course, more coverage of the flight and the moon exploits of Apollo 11. This is Peter Jennings in New York. Now back to Frank Reynolds.
Howard K. Smith is in our Washington studios, and he has some thoughts on this moment in our history. So let's go to Washington now and Howard Smith.
I'm told that there have been sporadic protests from television viewers at not being able to see their usual and favorite television programs this weekend, and there will probably be more complaints later on. I beg to suggest to complainants that they're seeing what television is really for. Too often we consider this medium just another method of watching movies and seeing what used to be called vaudeville without having the trouble of going to the theater. But its real value is to make people participants in ongoing experiences. Real life is vastly more exciting than synthetic life, and this is real-life drama with audience participation. When John Kennedy was assassinated, the nation was overripe for a burst of divisive bitterness. There's no doubt that by being made participants in that tragedy, Americans were purged of bitterness, and television was the cause of that. What the outcome of this participation of hundreds of millions of humans in an otherwise unbelievable human experience will be, we don't know. But as one newspaper commentator said today, we can be sure that things will not be the same again. There's one consolation for television viewers of this event. Reporters who go to political conventions have discovered that if they stayed home and watched television, they would find out more than by going to the convention. Well, you're watching on television and seeing things that one very important figure is not able to witness. He's Michael Collins, circling the moon, nearer than anybody else to the landing except the men who have landed. And he has been witnessing less than you. He doesn't have a TV receiver in his module, and you've got one in your home.
The day men reached the moon. It's been 2 hours, 18 minutes, 2 hours and 19 minutes, precisely as of now, since Eagle, the lunar module with Neil Armstrong as spacecraft commander and Buzz Aldrin as the lunar module pilot, stepped down on the moon in the Sea of Tranquility at a new place on the lunar landscape, now christened Tranquility Base. All has gone well. They have completed all their emergency liftoff checklist items and have been given the go to stay on the moon so far for the full length of their projected 21-hour and 27-minute lunar stay time. What's happening now up there is that at this point, Armstrong and Aldrin are scheduled to, and we have every reason to think they are, eating dinner like millions of other Americans. So, who can imagine any more unusual place for two Americans to have dinner than on the moon at this point? They've also been given the go by Apollo Control in Houston after eating to rest, then to begin their moonwalk at about 9 p.m. Eastern Daylight Time tonight. In an unusual reversal of procedures, a maneuver that was hinted at by Colonel Frank Borman about an hour or so in an interview with us here on ABC. Now here is Neil Armstrong, a tape playback of Neil Armstrong asking for the approval of Mission Control to begin the moonwalk early.
Quality over. Roger. Our recommendation at this point is planning an EVA with your concurrence starting at about 8 o'clock this evening, Houston time. That is about 3 hours from now. Stand by. We'll give you some time to think about that. Tranquility Base, Houston, we thought about it. We will support it. We're go at that time, over. Roger.
So that took care of that. And they have decided now to go ahead and have their EVA, their moonwalk, in, probably less than 3 hours from now. There has been, the definite times have not been decided because, as Jules just pointed out, Houston has told them that they want them to rest after having their dinner, or their lunch, or their breakfast, or whatever it is, but their food anyway in moon time. And then, after resting, they will break the hatch and decide to come out and walk in prime time, so to speak. Very good. By the way, Jules, you talked about them eating. While Peter Jennings was giving the news, we had AOS here. You know what AOS is?
No, Frank. What is AOS?
Acquisition of steak.
Very good. Very good. You win a bet on that, too.
Food was delivered here.
Very good.
Magnificent sight out here. Magnificent desolation. Dear men from the planet Earth, first set foot upon the moon.
Neil Armstrong and Buzz Aldrin have been on the moon for 4 hours and 30 seconds. 4 hours and 30 minutes, I'm sorry. It's been a long day here, too. As Jules said, at EVA, that walk out on the moon probably will begin about 45 minutes or so from now. And about 50 minutes after Armstrong steps out, when both Armstrong and Aldrin are on the lunar surface and have planted the American flag, that's when we expect to have the telephone call, the conversation, really between President Nixon in the White House and the men, the two Americans, on the moon. Man, of course, explored space and even landed on the moon long before Apollo 11. There's nothing new about this. At least as far as Hollywood is concerned, there's nothing new about it. We found a long line of space films, some of them in retrospect ridiculous, and some surprisingly accurate, and most quite prophetic. Here is Richard Schickel, the film critic for Life magazine and a student of those exciting space films, with ABC's Peter Jennings.
There was I guess the first serious or semi-serious picture to be made was by the Frenchman Méliès in 1902. Was it really designed to have a serious view of the moon?
No, I don't think so. I think he designed it as a satire on a story of H.G. Wells, which was very popular in those days.
Published a year earlier.
Published a year earlier. And Méliès was a kind of great man. He's really the first genius of the movies. He invented things like the fade out and the dissolve. But the most important thing about him was he was the first man to realize that you could arrange scenes to tell a story. Before that, we just had kind of postcard views in movies. So he was the first storyteller in the movies.
Here then is the first story tale, or the first fairy tale at least, of a man going to the moon. 1902 this is.
That's first meeting of NASA, I think.
Or the debate about what flag will be planted on the moon. Young ladies, incidentally, are from the Folie Bergère.
Yes, and I think they're a very nice feature for liftoffs.
Here the concept was, of course, firing the rocket out of a cannon. And people considerably closer to the launch pad than anything else.
That's right. You'll see it's a very good, accurate launch. Now, this is something he really did take from Wells, which is the notion that moon people lived in caves. They thought that possibly the craters, which they saw through the telescopes, were the entrances to vast caves, and that maybe there was a civilization down there, underground.
These were the moon people, of course.
Right, he's actually an acrobat from Folie Bergère, entertaining the tourists.
The moon at that time basically always, didn't it, have an image of people living on it?
Yes, I think it did. And not very friendly ones either.
That's a technique I never expected to see in 1902.
Oh, this is the thing that Méliès, having been a magician, was so good at it. His effects are so marvelous, I think.
Re-entry takes a somewhat more primitive form in this film today.
Here now, you're going to see history's very first splashdown.
It's amazing where NASA picks up its ideas. How that great cast iron thing descends from the moon and floats as well. And Méliès' version of the USS Hornet. That's funny, but strange how accurate. Now, here's a film that Dick has prepared, which shows there was some very serious thought about communicating with outer space.
Yeah, this is about 20 years later. It's done by two people, John Bray, who was a very early animator, and Max Fleischer, who went on to do Betty Boop and Popeye and things like that. They're trying to explain moon atmosphere.
Neither Aldrin or Armstrong, of course, are going to find work on the moon a pleasure, it's going to be very tedious. But there are a couple of things here which indicate this, for example, that one of the ways to move on the moon is with a kind of kangaroo hop, though not necessarily that far. How could you be opposed to this kind of outer space idea?
By the same people, and they're trying to talk about communications between the planets. And Professor Pickering, of course, really existed, and this indeed was his plan, which I think probably had some help on from Rube Goldberg.
Mechanical arrangement.
Yeah, it's a giant hinge.
Of course, that hasn't changed much either. NASA today uses language that the layman can hardly understand.
Well, that's true. I think there's something very charming about these ideas, because in those days, in the 1920s, we had to depend on mechanics rather than electronics to do a lot of the things that are easy now. And so these kind of great, goofy ideas were proposed.
Essentially, isn't it?
I don't know what makes them think that necessarily on Mars they understand Morse code, but...
The plan here was always, too, to communicate with Mars, wasn't it, rather than the moon?
Right, I think they've given up on the idea that there was anything on the moon to talk to, anyway.
A response which would probably scare the devil out of anybody. How do these things stack up to a film critic?
Well, as film, not much, but I think there's something kind of touching about our desire to communicate, to kind of get in harmony with the spheres, as it were. I think it's a long-standing desire of man, and so something touching about it, really.
They're fascinating. Thank you very much, Dick Schickel from Life.
It does seem appropriate that as man is about to set foot on the moon for the first time in the history of mankind, that we should honor this event and celebrate it with music. So ABC News asked a most distinguished musician to compose and perform an original piece for this occasion. He is a member of the National Council on the Arts. He holds about a dozen honorary PhDs. Last April, when he was 70 years old, President Nixon awarded the composer the Medal of Freedom at a gala White House birthday party. And here in ABC Space Headquarters is the Honorable Dr. Edward Kennedy Duke Ellington.
Thanks very much, Frank. I'm very much honored indeed to be invited here today to help celebrate this great occasion. Matter of fact, I'm so inspired that I think I shall attempt to make my debut as a vocalist with Moon Maiden. How about that? Moon Maiden. Way out there in the blue. Moon Maiden. Got to get with you. I made my approach and then revolved. But my big problem is still unsolved. Moon Maiden, listen here, my dear. Your vibrations are coming in loud and clear. Now, I'm just a fly-by-night guy, but for you, I might be quite the right do-right guy. Moon Maiden, Moon Maiden. Listen here, my dear. Your vibrations are coming in loud and clear. Now, I'm just a fly-by-night guy, but for you, I might be quite the right do-right guy. Moon Maiden. Moon Maiden.
I wanted to write a poem which attempts to give some of the thoughts and feelings one of the astronauts on the moon is having when he first touches the ground of the moon. These are the only men in this world, and on the moon, the only men who have ever been there, at least so far as we know. And they've brought the whole human mind and all the cycles of civilization and history, including mythology, with them. It seems a strange and wonderful thing to me that the spaceship that brought them to the moon should be named Apollo, who is also the Greek god of poetry. The poem is supposed to be spoken by one of the astronauts on the moon to the other one, whose face visor is reflecting the Earth. The poem is called The Moon Ground. You look as though you know me, though the world we came from is striking you in the forehead like Apollo. Buddy, we have brought the gods. We know what it is to shine far off with Earth. We alone of all men could take off our shoes and fly. 1/6 of ourselves we have gathered, both of us, under another one of us overhead. He is reading the dials. He is understanding time to save our lives. You and I are in earth light and deep moon shadow on magic ground of the dead new world. And we do not, but we could, leap over each other like children in the universal playground of stone. But we must not play at being here. We must look. We must look for it. The stones are going to tell us, not the why, but the how of all things. Brother, your gold face flashes on me. It is the Earth. I hear your deep voice rumbling from the body of its huge clothes. Why did we come here? It does not say, but the ground looms, and the secret of time is lying within amazing reach. It is everywhere we walk, our glass heads shimmering with absolute heat and cold. We leap slowly along it. We will take back the very stones of time and build it where we live. Or in the cloud-striped blue of home, will the secret crumble in our hands with air? Will the moon plague kill our children in their beds? The human planet trembles in its black sky with what we do. I can see it hanging in the God gold only brother of your face. We are this world. We are the only men. What hope is there at home in the azure of breath, or here with the stone-dead secret? My massive clothes bubble around me, crackling with static, and Gray's elegy helplessly coming from my heart. And I say, I think something from high school. I remember now fades the glimmering landscape on the sight, and all the air a solemn stillness holds. Earth glimmers, and in its air color a solemn stillness holds it. Oh, brother, earth-faced God, Apollo, my eyes blind with unreachable tears. My breath goes all over me and cannot escape. We are here to do one thing only, and that is rock by rock to carry the moon, to take it back. Our clothes embrace. We cannot touch. We cannot kneel. We stare into the moon dust, the earth-blazing ground. We laugh with the beautiful craze of static. We bend. We pick up stones.
This is not the time to run down to your neighborhood drugstore for something that you may have forgotten, because we're getting very, very close now to the time when we will hopefully see the pictures of man stepping on the moon, Neil Armstrong. All around the world right now, all around this world, people are gathering in front of television sets, and in some places they're gathering in rather large numbers. Central Park in New York, in the sheep meadow, it's been renamed Moon Meadow for tonight. And despite some adverse weather, I really do not know whether it is still raining in New York. But people are out, and they're waiting to see the first man step on the moon. They've been invited by the mayor, and this you might say is one night that it's all right to walk through Central Park. Originally, the idea was to wear white. I've never quite been sure why that was the preferred mode of dress. But they all seem to be having a rather good time, don't they?
Participatory moon madness.
With TV,
Let's go to Houston now. They're in conversation with the astronauts. I don't know.
They hear everything but that. Houston, this is Tranquility. We're standing by for a go for cabin depress, over.
Tranquility Base, this is Houston. You are go for cabin depressurization. Go for cabin depressurization.
Go, cabin depressure. Roger, thank you. Coming down. There you go. Open the hatch when we get to 0. Base 5 clear.
Roger. And we're getting a picture on the TV.
You got a good picture, huh?
There's a great deal of contrast in it, and currently it's upside down on our monitor, but we can make out a fair amount of detail.
Okay, would you verify the position, the opening I ought to have on the camera?
Stand by. Okay, Neil, we can see you coming down the ladder now.
Neil, we can see you coming. Okay, I just checked getting back up to that first step. That isn't collapsed too far, but it's adequate to get back up.
Roger, we copy.
It's a pretty good little job.
Buzz, this is Houston. F2, 1/160th second for shadow photography on the sequence camera.
Okay. I'm at the foot of the ladder. the LEM footpads are only depressed in the surface about 1 or 2 inches, although the surface appears to be very, very fine-grained as you get close to it. It's almost like a powder. Ground mass is very fine. I'm going to step off the LEM now. That's one small step for man, one giant leap for mankind. As the surface is fine and powdery, I can pick it up loosely with my toe. It does adhere in fine layers, like powdered charcoal, to the sole and sides of my boot. I only go in a small fraction of an inch, maybe an eighth of an inch, but I can see the footprints of my boots and the treads in the fine sandy particles. Aeolus, this is Houston. We're copying. There seems to be no difficulty in moving around as we suspected. It's even perhaps easier than the simulations of 16G that we performed in various simulations on the ground. Absolutely no trouble to walk around. Okay, the descent engine did not leave a crater of any size. It has about 1 foot clearance on the ground. We're essentially on a very level place here. I can see some evidence of rays emanating from the descent engine, but very insignificant amount. Okay, Buzz, we ready to bring down the camera? I'm all ready. I think it's 2 miles squared away in good shape. Okay. Okay, you'll have to pay out all the LEC. It looks like it's coming out nice and evenly. Okay, it's quite dark here in the shadow and a little hard for me to see that I have good footing. I'll work my way over into the sunlight here without looking directly into the sun. Okay, it's taut now. Unofficial time on the first step, 109.2420. That's the sample return containers, the rock boxes that Capcom... Now I want to back up and partially close the hatch. Making sure not to lock it on my way out. Particularly good thought. That's our home for the next couple of hours. We want to take good care of it. Okay, I'm on the top step, and I can look down over the RCU and landing gear pad. That's a very simple matter to hop down from one step to the next. Yes, I found it to be very comfortable, and walking is also very comfortable. You've got 3 more steps and then a long one.
Okay, I'm going to leave that 1 foot up there and both hands down to about the 4th rung up.
There you go.
Okay, now I think I'll do the same.
A little more. About another inch. There, you got it? That's a good step. Yep. About a 3-footer.
Beautiful view.
Isn't that something? Magnificent sight out here.
Magnificent desolation.
Both PLSS is nominal on consumables.
Looks like the secondary strut. Have little thermal effects on it right here, Neil.
Yeah, I noticed that. Seems to be the worst, although similar effects are on all around.
It's very, very fine powder, isn't it?
Isn't it fine?
Right in this area, I don't think there's much of any but fine powder. Some clouds together, and it's hard to tell whether it's a clod or a rock.
Notice how you can pick it out.
Yeah, and it bounces and then... Reaching down, fairly easy. Get my suit dirty at this stage. The mass of the backpack does have some effect in inertia. Slight tendency I can see now to backwards due to the soft, very soft texture.
Hey, you're standing on a big rock there now.
Sure didn't.
No, it didn't.
Absolute no crater there at all from the engine.
No.
I wonder if that right under the engine is where probe might hit. I'd like that.
Yeah, I think that's a good representation of our sideward velocity of touchdown. That folded the probe.
I'll see that probe over on the minus Y strut. Open off and bent back up.
That did, didn't it? Other 2 boats bent over.
Say too much for the visibility right here without the visor up. Pretty dark. It looks like there's
surface of a flat, rounded rock. And incidentally, these rocks, very powdery surface.
Say again, please, Buzz. You're cutting out.
And just I say that the rocks are rather slippery.
Roger.
Very powdery surface when it's on there. Fill up all the very little fine porises. They'll tend to slide over it rather easily.
Neil Armstrong getting ready to move the TV camera now out to its panorama position.
Traction seems quite good. Picture area. Start to lose my balance in one direction, and recovery is quite natural and very easy. Moving arms around, Jack doesn't go off the surface. Not quite that light-footed. And I have the insulation off the mesa now. The mesa seems to be in good shape. You have to be careful that you're leaning in the direction you want to go, otherwise you slightly inebriate. In other words, you have to cross your foot over to stay underneath where your center of mass is. Hey, Neil, didn't I say we might see some purple rocks? Find the purple rocks? Nope. Very small, sparkly fragments are rock. They're like the sun in places. I would make a first guess at some sort of biotite. I'll leave that to the further analysis. Underneath. No, you don't sink down more than a quarter of an inch.
Biotite is a brown mica substance.
Okay, Houston, I'm going to change lenses on you.
Roger, Neil.
Neil is now unveiling the plaque that is...
Roger, we got you bore-sighted, but back to one side.
Bore-sighted? For those who haven't read the plaque, we'll read the plaque that's on the front landing gear of this LEM. There's two hemispheres, one showing each of the two hemispheres of Earth. Underneath it says, "Here men from the planet Earth first set foot upon the moon, July 1969 AD. It came in peace for all mankind." It has the crew members' signatures and signature of the President of the United States. Ready for the camera? I'll get it. Okay, you're taking TV on now. That's the LEC there. I'm afraid these hard materials are going to get rusty. Yeah, surface material powdery. I don't know how good your lens is, but if you can touches above. Very much like a very finely powdered carbon, but pretty looking. Can you pull out some of my cable for me, please? Houston, how close are you able to get things in focus?
This is Houston. We can see Buzz's right hand. It's somewhat out of focus. I'd say we were focusing down to probably about 8 inches to a foot behind the position of his hand when he was pulling out the cable. Roger, you look okay as far as distance goes, Neil, and we'll line you up again when you finish the panorama. You're going too fast on the panorama sweep. You're going to have to stop for...
I haven't stopped. I haven't set it down yet. That's the first picture in the panorama. Right there.
Roger.
It's taken just about northeast. Tell me if you got a picture, Houston.
Well, we've got a beautiful picture, Neil.
Okay, I'm going to move it.
Okay, there's another good one. Okay, we got that one.
Okay, now this one's right down sun, straight west. And I want to know if you can see an angular rock in the foreground.
Roger, we have a large angular rock in the foreground, and looks like a much smaller rock a couple of inches to the left of it. Over.
All right, and then on beyond it, about 10 feet, is an even larger rock that's very rounded. That rock is about, the closest one to you is about sticking out of the sand about 1 foot. It's about 1.5 feet long, and it's about 6 inches thick, but it's standing on edge.
Roger.
Okay, Neil, I've got the table out. Got a bag deployed.
We got this view, Neil.
Straight south.
Roger, and we see the shadow of the limb.
And the hill, Roger, the little hill just beyond the shadow of the limb is a pair of elongate craters. Probably the pair together is 40 feet long and 20 feet across, and they're probably 6 feet deep. We'll probably get some more work in there later.
Roger, and we see Buzz going about his work.
How's that for a final?
For a final orientation, we'd like it to come left about 5 degrees, over. Back to the right about half as much.
Okay.
Okay, that looks good there, Neil.
Yeah, that looks good there, Neil. Okay.
One hour, 7 minutes time expended.
Okay, you can make a mark, Houston.
Roger, roll in.
And incidentally, you can use the shadow that the staff makes to assist you in getting it perpendicular.
Buzz is erecting the solar wind experiment now.
Some of these small depressions, big soft, and you tend to think, oh, maybe 2 or 3 inches. I can suggest exactly what the layer pictures showed when they pushed away a little bit. You can see force transmitted through the upper surface of the soil, and about 5 or 6 inches away, it breaks loose and moves as if it were caked on the surface, when in fact it really isn't. I noticed in the soft spots where we have footprints nearly an inch deep that the soil is very cohesive, and it will retain a slope of probably 70 degrees on the side of the footprint.
Neil Armstrong's been on the lunar surface now almost 45 minutes.
I don't remember.
Columbia, this is Houston, reading you loud and clear, over.
Yeah, this is Houston reading. Yeah, radio loud and clear. How's it going?
Roger, the EVA is progressing beautifully. I believe they're setting up the flag now.
Great.
I guess you're about the only person around that doesn't have TV coverage of the scene.
That's all right, I don't mind a bit. How is the quality of the TV?
Oh, it's beautiful, Mike. It really is.
Oh, geez, that's great. Is the lighting halfway decent?
Yes, indeed. They've got the flag up now, and you can see the stars and stripes on the lunar surface.
Up now, and you can see the stars and stripes on the lunar surface. Beautiful, just beautiful. If you can pull that end off a little bit. Tighten that end up a little. It won't go out.
is Houston, radio check, over.
Hi, Roger. Houston, loud and clear.
Roger out.
Loud and clear, Houston.
Roger, Buzz.
To evaluate the various paces that a person can traveling on the surface. I believe I'm out of your field of view. Is that right now, Houston?
That's affirmative, Buzz. You're in our field of view now.
You do have to be. All right, you do have to be rather careful to keep track of where your center of mass is. Sometimes it takes about 2 or 3 paces to make sure that you've got your feet underneath you. And about 2 or 3 or maybe 4 easy paces can bring you to a fairly smooth stop. Direction. Like a football player, you just have to put out to the side, cut a little bit. So-called kangaroo hop does work, but it seems your forward stability is not quite as good as it is in the more conventional one foot after another.
Tranquility Base, this is Houston. Could we get both of you on the camera for a minute, please?
Say again, Houston.
Roger, we'd like to get both of you in the field of view of the camera for a minute. Neil and Buzz, the President of the United States is in his office now and would like to say a few words to you. Over.
That would be an honor.
Go ahead, Mr. President. This is Houston out.
Hello, Neil and Buzz. I'm talking to you by telephone from the Oval Room at the White House. And this certainly has to be the most historic telephone call ever made. I just can't tell you how proud we all are of what you... For every American, this has to be the proudest day of our lives. And for people all over the world, I am sure they too join with us in recognizing what an immense feat this is. Because of what you have done, the heavens have become a part of man's world. And as you talk to us from the Sea of Tranquility, it inspires us to redouble our efforts to bring peace and tranquility to Earth. For one priceless moment in the whole history of man, all the people on this earth are truly one. One in their pride in what you have done, and one in our prayers that you will return safely to Earth.
Thank you, Mr. President. It's a great honor and privilege for us to be here representing not only the United States, but men of peace of all nations, and with interest and a curiosity and with a vision for the future. Honor for us to be able to participate here today.
Thank you very much, and I look forward, all of us look forward to seeing you on the Hornet on Thursday.
Look forward to that very much, sir. Neil and Buzz, this is Houston. We'd like you to... You're right. Turn to your right. Not clear? Not quite. Neil, this is Houston. We'd like you all to get 2 core tubes and the solar wind experiment. 2 core tubes and the solar wind, over. Roger.
The core tubes provide material.
Get the next one. Maybe you can turn away the box a little bit. Yeah, I'll take care of it.
While they've already learned a great deal about the lunar surface from their own observations, certainly the information that they bring back with them, not just the materials that come back with them, will be of inestimable value to scientists. And all the rest of us have learned a great deal about them and I guess about ourselves today.
Buzz, this is Houston. You have approximately 3 minutes until you must commence your EVA termination activities. Over.
Roger, understand.
Buzz understands, but I have the feeling he's not too enthusiastic about terminating his...
Columbia, this is Houston. Approximately 1 minute to LOS. Over.
1 minute. Columbia, roger.
And do you plan on commencing your sleep on the backside this pass? If so, we'll disable uplink to you while we're talking to the LEM. Over.
While we're talking. Negative that. Houston, were you able to record in a documentary way where the two samples were taken?
Negative.
Now, I didn't get a stereo pair of those two, but they're right in the vicinity of the solar wind.
Neil, this is Houston. After you've got the core tubes and the solar wind, anything else that you can throw into the box would be acceptable.
I do. Cap was right. I got the cap. Got the cap? They're both good caps on around. Okay. And you want to pick up some stuff and I'll get these receptacles. Throw the solar wind in.
have to remember as you see them almost soaring about there.
Buzz Aldrin retrieving the solar wind experiment.
With all that equipment on, they would weigh 300 pounds on Earth. But only 50 pounds lunar gravity. They're so very businesslike and calm about it. And yet it's still incredible to sit down here and look up there at them.
Buzz, this is Houston. It's about time for you to start your EVA closeout activities.
Roger.
They've been on their life support system. On their life support systems, 2 hours and 25 minutes.
And those Aldrin will be getting ready to go back inside.
Adios, amigos. Hey. Anything more before I head on up, Bruce?
Negative. Head on up the ladder, Buzz.
Head on up, Buzz.
Capcom Bruce McCandless in Houston. And I don't think the
Okay,
decision...
you can just kind of hold it, but I think I can do the pulling. Okay?
That's Aldrin pulling up the sample return container last
Stand by a minute. Let me move back.
It's not as easy as it seemed at the beginning. And also, they've had a very long day. They've been up for 18 hours and 10 minutes now with no rest break in between since 7 a.m. Had only about 5 or 6 hours sleep last night. I still think they were wise to start
Okay, I'll get it the rest way.
this moonwalk earlier than planned.
And I'll give it to you to go away just a second. And a little more.
Hours, 40 minutes on the PLSSs.
Which had been the optimum time, of course, the planned time for ending the moonwalk. But the workload has seemed somewhat less than originally thought, and their supply of consumables, both coolant and oxygen, going into
How about that package out of your sleeve? Get that? No. Okay, I'll get it. I get up there.
There's Neil. Don't know quite what you'd call that step.
That's all.
You mean the one at the bottom? The motion of the step is, well, it's quite unlike any other thing there is. Oh, the moon hop? The moon hop. Good term. There he is moving up by the, I'll call it the MH. MH.
Neil, this is Houston. Did you get the Hasselblad magazine?
How about an NAMH?
Yes, I did. And we got about, I'd say 20 pounds of carefully selected, if not documented, samples.
Houston, Roger. Well done. Out.
At the second box.
Neil was relaying word he didn't have time to really document the samples, but got 20 pounds of materials into the boxes full of carefully selected, too.
Unofficial time off the surface at 1:11:37:32.
Start arching your back. That's good. Plenty of room. Plenty of room. All right, arch your back a little, your head up again.
Neil heading back in now.
Roll right just a little bit. Head down. And in good shape. Thank you. Pipe open now. Now you're clear. You're rubbing up against me a little bit. Okay. Turn. All right, that's right.
Armstrong was out on the surface 2 hours and 8 minutes by our calculation.
Move your foot and I'll get the hatch. Okay.
And perhaps most difficult,
Okay,
two-thirds.
the hatch is closed and latched.
Hatch closed. Apollo 11 landed on the moon. Eagle landed on the moon. They have completed their EVA. They have gathered up their rock samples. They have deployed the various scientific experiments. And voice communications have now been reestablished quite clearly between Houston and Eagle. Both Neil Armstrong and Buzz Aldrin are back inside now, closing out their activities and getting ready for what will be certainly some very well-deserved rest. Let's go to Bill Brannigan, who is in Los Angeles, and he covered today's moon landing on the beach.
So this is no ordinary summer weekend. They're on the moon.
We copy you down, Eagle.
The Eagle has landed. While the volleyball rises and falls, and while the surf comes up and goes down, Southern Californians are aware there is a man on the moon. This is Bill Brannigan, ABC News, Los Angeles.
Here's what happened at Comiskey Park in Chicago. Ball game.
The game is in the 7th inning. Kansas City against Chicago. In Chicago, the time is 3:17. The astronauts are just about to land on the moon. And the 16,000 fans here at the ballpark are preparing to do what nearly every other American will do at this moment: celebrate and applaud the space achievement by America. Here's how they're doing it at White Sox Park.
Ladies and gentlemen, we thank you.
Action by 16,000 fans at the Sunday afternoon ball game. An unusual, but this time very welcome, interruption. This is Hugh Hill reporting from White Sox Park in Chicago.
Well, we thought we'd talk a bit about science fiction. The guest we just had on Houston mentioned future flights. And, of course, a good many people laugh about science fiction, but I should imagine today, and especially after watching those fantastic pictures from the surface of the moon last night and early this morning, people are not quite laughing so readily anymore. We have now discovered that science fiction is, to a surprising degree, non-fiction. 4 science fiction writers are here to talk about their literature and the moon.
Well, gentlemen, we sit here in the aftermath of this incredible adventure of man, this odyssey of reaching out into space and, in a sense, laying claim to it by our landing on the moon, and looking at you 3 gentlemen who have been such qualitative practitioners of the science fiction art. The question immediately comes to mind, since you've been pretty remarkably accurate in your predictions in the past in your writing. Did all of you or any of you predict this landing on the moon? And if so, when did it occur? When did you think it did? We'll start with you, Fred.
I didn't predict the landing at any particular time. It was inevitable. It was just one of those things that had to happen. And I expected it to happen within my lifetime. And I'm glad to see that I made it.
And you, John?
It's much the same thing. I was a believer in science. I was a believer in science fiction. All this would come to pass. It was a fixture of the present in those days. for me. It's only a picture of the present now for others.
Did you touch upon thematically the landing on the moon?
Not the landing on the moon, no. My few space stories were full of pirates and trips to Mars.
And here's the Peck's bad boy of science fiction writers right over here. Isaac, what about you?
Well, I tell you, back in 1939, I wrote a story about the first trip to the moon. I placed it in 1973, which shows that crackpot though I was very conservative. The only thing was I followed science fiction tradition by having the first spaceship built by a sole inventor, a Lone Eagle type fellow, who built it out of old tin cans in his backyard. And he went around the moon in it without anybody's help. Came back, landed in a tree or something. He said, I've been to the moon.
Well, you say that half in jest, but it is true thematically that in most early science fiction, it was the Lone Eagle concept, was it not? The sense of one man facing the unknown rather than the crew idea?
Sure, and not only did they build a spaceship in their backyards and take off the next day, but they didn't stop at the moon. Doc Smith had a fellow who was working as a chemist at the National Bureau of Standards one afternoon. 2 days later, he had conquered the whole galaxy in the skylark of space.
But I think that that was important, you know. I was lured into science and engineering by science fiction, and if I'd had any idea how hard it was, I might never have arrived here.
I wonder about that, John. I think in your case it must have been preordained. But having reached this plateau, this lunar plateau, immediately it comes to mind, what is the next basic thematic area for the science fiction writer? We have touched upon the moon. We have, in a sense, predicted it as science fiction writers. I use the collective, respectful we here, and that's certainly not me. What do you write about next? Where does man go in his science fiction beyond the moon? Isaac?
Well, one of the themes I've made use of a great deal has been the man-like robot with man-like intelligence. Now, this is still in the future, and on the other hand, it's still something we're likely to accomplish. So I, for one, plan to stand pat on this to a great degree. I shall continue writing robot stories. I think that for my lifetime anyway, they'll remain science fiction.
There will be no live television now of the liftoff. The television camera that relayed those spectacular pictures last night of the walk on the surface of the moon has been deactivated. Matter of fact, it's going to be left there. And so there will be no live television. Perhaps on future missions, future takeoffs, there may be, but not today. We will, of course, have voice communication, however, and you will be able to hear Houston talking to Eagle, talking to Neil Armstrong and Buzz Aldrin as they take off.
After the scientific experiments have been completed, and when the command module comes back overhead within range of their rendezvous radar, Neil Armstrong and Buzz Aldrin prepare to launch off the moon's surface. Mike Collins joins Armstrong and Aldrin in a combined countdown that will end the first part of this historic journey. The ascent engine is fired, lifting the ascent stage into a 10-mile-high transfer orbit, the first step to rendezvous with Collins. The descent stage, which serves as a launching pad, remains on the moon together with the lunar surface experiments. These packages will continue to transfer information on moonquakes and lunar coordinates to Earth for as long as a year. The ascent stage is shut down at 60,000 feet over the moon. If problems have occurred and Armstrong and Aldrin can't reach lunar orbit, then Collins and the command module can fly down as low as 35,000 feet to rescue them. Then, after getting into lunar orbit, the astronauts maneuver using their reaction-controlled jets to place the spacecraft in an intercept trajectory with the command module. Rendezvous radar measurements are used to guide the approach from 350 nautical miles down to the last 500 feet. During the docking maneuver, the lunar module is under manual control. This is the last of 4 critical maneuvers that Apollo 11 will accomplish. Rendezvous after liftoff from another planet, a critical maneuver never before tried by any space crew. The other 3 critical maneuvers, of course, power descent, touchdown, and then ascent to lunar orbit. The 2 craft hopefully will be in a continual line-of-sight relationship with each other during the rendezvous maneuver. Lem is pitched over to bring the command module docking target clearly into view through its upper window. After lining up on the command module's docking target, the commander then maneuvers his vehicle closer. Then Mike Collins in the Apollo command module, who has a far better window view, powers up, moves in, and completes the docking.
very close now to Houston so that we can hear any air-to-ground communications.
Guidance reports both navigation systems on Eagle are looking good.
Just keep fine. That's it, answered, Coach. Proceed. 26, 36 feet per second up. 5, little pitch over. Very smooth. Let's couple off. Very quiet ride. There's that one crater on there.
Lifting off beautifully.
1,000 feet high, 80 feet per second vertical rise. Eagle Houston, request manual start override. Roger. 2,600 feet altitude. Clear. No. Eagle Houston, 1 minute, you're looking good. Roger.
News. Buzz Aldrin again. Armstrong doing the flying. A beautiful liftoff. Scratchy communications. Eagle taking off just the way it's supposed to.
Vertical rise rate.
A little bit of slow wallowing back and forth. Not very much thruster activity.
Roger, mighty fine.
$100, 150 up, beautiful. 9,000. Ag degrees within a foot per second.
Eagle Houston, you're looking good at 2. Pings, ags, and lifts in, all agree.
That's 1,000. 170 up, beautiful. 14,000.
Right on the money, exactly where they're supposed to be. The engine burning perfectly.
And a foot per second again, ags to ping. That span looks like it's holding good, Houston.
Roger, we concur. It's great.
1,500, 185.
The Eagle's already 160 miles away from its landing site.
Aldrin is reading the horizontal velocity first, and then the vertical velocity. It's now 1,424 feet per second vertical velocity, 187 vertical velocity. Eagle Houston, your go at 3 minutes. Everything's looking good.
Roger.
Nearly 200 miles downrange from Tranquility Base.
Right on H-Dot. Coming up to, this is H-Dot max now. I got right down UF1.
Roger.
Armstrong there for the first time.
Height's now approaching 32,000 feet.
And Eagle's up to about 1,700 miles an hour, really streaking along.
Eagle Houston, 4 minutes. You're going right down the track. Everything's great. Horizontal velocity approaching 2,500 feet per second.
That's the bean outflow right now.
Roger.
That's the crater Sabine, exactly where it's
Some 120 miles to go until insertion.
And they're around 220 miles downrange from Tranquility Base.
240 to go.
Two and a half minutes more of engine burn needed, called for, before they insert. 260 miles downrange.
There's Ritter out there. There it is, right there. Ritter Schmidt. Hey, that's impressive looking, isn't it?
Crater Schmidt is soaring by.
Houston, you're great. 3 looking guy, 155.
All three data sources are agreeing quite closely here. The 3-color plot board on the front of mission control here is almost superimposed, as each of the 3 colors are scribed on the scribing plotter.
Eagle now approaching 48,000 feet altitude.
Iron Aqua, I think, it's up to the right.
And high overhead, Columbia, the command module, with Mike Collins orbiting at 69 miles, leading them by about 3 miles.
Eagle Houston, you're still looking mighty fine. I think good agreement in Delta V to go on both eyes and things. Roger.
6 minutes into the engine burn, Eagle doing 3,300 miles an hour through 55,000 feet altitude. An orbit now virtually a certainty.
1 minute to go in the burn. 4,482 feet per second. Horizontal velocity.
Command
100 to go.
Command module pilot Collins pointed down.
100 to go. Okay, and open up the main shut-off. FS6 goes, pressure's holding good, cross speed off. 250 to go.
Almost as fast as they need to. Very close.
And we're on the engine arm. 90, okay, off, 50, shut down.
Right on schedule. They've got it made. We're in orbit.
We got 53373, 32.8 feet per second, 60,666. Eagle Roger, we copy, it's great, go. And we got our residuals. Yeah, take. Eagle Houston, trim residuals.
Showing a paraloon of 9.1 nautical miles, apoloon 47.2 nautical miles on the pings. All 3 systems are go.
A little bit low.
Velocity showing about 55, 37 feet per second, plus or minus a foot or so on each of the 3 systems.
A little bit low on the paraloon, but easily taking them into orbit. No problem.
Last week, when Apollo 11 was launched on its way from Cape Kennedy, one of the guests there to witness the launching was former President Johnson, who was moved to remark after the launch that he wondered why, if we can harness all this technology and put together all this effort, we can't do the same to bring peace to the world. Well, we have to remind ourselves of the fact that while we have done all these wondrous things in space and with our technology, we still have not been able, some way or another, to eradicate war from the face of the earth, and there is a war underway right now, though hopefully it is in what is called a lull. Perhaps the young men who were actually doing the fighting might quarrel a bit with that description of it. But nevertheless, the flight of Apollo 11 has great meaning, too, for the young men, Americans and South Vietnamese, and for that matter, North Vietnamese and VC in Vietnam. And we thought it would be interesting to see how they feel about it. ABC's Kenneth Gale has this report on the reaction of American troops in the combat zone in Vietnam.
It was early in the morning, a full 2 hours before sunup here in Vietnam, when man reached the moon. Out in Tay Ninh province, troops have been tense for several nights now, waiting for the heavy fighting to begin again. For that reason, most of those who did not have to be awake slept through the moon landing, knowing they will not sleep when the fighting begins. Artillerymen were awake, firing wherever the enemy might be. Because of the clouds, the only moon to be seen over Tay Ninh was an artificial one, flares to keep the enemy from moving in darkness. In a bunker, a night radio watch followed the moon landing with an ear tuned to other radios that might call them to action at any time. Artillery Fire Direction Control Office here at Fire Support Base Buell. Lieutenant, do you think the moon shot was worth it, all this?
Well, it depends what you mean by worth it. From a technological point of view, it was a wonderful accomplishment. Being a romanticist that I am, I feel that men should more or less try to square away their affairs here in this world before they go exploring the stars and the planets. And this is being a first step into the universe. Well, it was the accomplishment itself was worth it. But I think that people are putting too much stock into space travel when they should try to square away what's wrong with this world right here.
Luckily, the night was relatively quiet at this artillery base in Tay Ninh. The men here actually more concerned with the immediate threat to their own lives to give much thought to the dramatic challenge facing the men on the moon. Kenneth Gale, ABC News, at an artillery base in Tay Ninh, South Vietnam.
Back in ABC Space Headquarters in New York, I'm Frank Reynolds with Jules Bergman. We are less than 15 minutes away now from the time when the rendezvous will be accomplished and the docking actually will take place, when the command module, Columbia, will be joined together now with the Lem, Eagle, Collins, Aldrin, Armstrong. I'm so tired that I'm having difficulty remembering those names now, you know.
Sure you weren't.
Just kind of slip away. We'll all be back together again in the same space capsule. We have an animation to show you just precisely how that is going to be done, how this docking maneuver will be carried out. We're 13 minutes away.
And they'll be coming out from behind the moon shortly. They should be fairly close together, Frank, when we arrive back in the radio signal area. And this is the way it'll look from inside Eagle, the lunar module. These are the rendezvous maneuvers that led up to the final rendezvous in the docking, the Eagle lunar module's ascent stage with the two astronauts aboard, moving in close as it will be in a few minutes, braking gates being applied, firing its reaction control system thrusters to slow down so it doesn't come in too fast to the Eagle, to the Columbia command module. Then when they're close by, rotating itself around into the docking attitude, a very difficult maneuver. The astronauts, Aldrin and Armstrong, looking out their top rendezvous maneuver, as we see in this animation. And as they move in with about 30 feet or so, then astronaut Michael Collins, inside the Columbia command module, takes the controls and fires up his reaction control system thrusters and moves in very slowly because he has better view of the target docking adapter. And the probe and drogues lock, meet, and the latches close, and they are docked. Shortly thereafterward, they will transfer from the lunar module back into the Columbia command module. Eagle, the lunar module, will be cast off into lunar orbit. Eventually, it will impact the moon months from now, perhaps. The three astronauts will eat and rest inside the Columbia command module. Not yet clear is whether Neil Armstrong, the spacecraft commander, will elect to extend their time, their lunar orbit stay time, if you will, for an additional 8 hours or 12 hours for a rest cycle, or whether he will stick to the original flight plan, which calls for a trans-Earth injection at about 1 a.m. The Eastern Daylight Time tomorrow morning to head them back on the 2.5-day journey toward Earth, which will climax successfully, we trust, in a splashdown on the Pacific about 12:52 p.m., that time subject to a few minutes revision, 12:52 p.m. Eastern Daylight Time this Thursday. We'll go to mission control now for air-to-ground signals.
This is Lunar Revolution number 27 for Columbia.
Terry White and mission control there, still waiting for confirmation of acquisition of radio signal as the clock ticks down to the docking.
Aeolus.
There's the signal Lem has been acquired. Eagle. And we should have Columbia acquired shortly. One or both of their antennas are out of position, and Houston apparently doesn't want to bother them with it while they're in this critical docking phase.
Okay, we're all yours. Columbia. Okay.
That's it. Armstrong giving Collins a signal to move in for the docking.
Okay, I have thrusters B3 and C4 safety. Okay.
And from every sign, they are already docked. Collins, in the brief exchange we heard, is going through his post-docking checklist, pressurizing the command module cabin up to 5.5 psi, disabling the two thruster jets you heard him mention, B3 and B4, in preparation for the...
That was a funny one, you know. I didn't feel it touch, and I thought things were pretty steady. I went to retract there, and then that's when all hell broke loose.
I put the vortex thrust to it. Apparently it wasn't finished, but somehow or other, that's when we got off an attitude, and then the attitude hold system started firing.
Yeah, that was sure busy there for a couple seconds.
And they are docked. Some small problems in attitude control being discussed by Mike Collins and Spacecraft Commander Armstrong.
I got a horrible squeal.
Yeah, I agree with that, but we hear you okay.
Houston, Apollo 11, over.
Apollo 11, Houston, go.
Roger, I'm supposed to adjust the oxygen flow in this thing to 0.6 of a pound per hour, but being as how this transducer is not working right, can you give me an updated number?
Affirmative. You want to go ahead and adjust your O2 flow until it just goes off the peg. And then crank the direct O2 valve back down about 5 degrees. Over.
Well, you're really waiting for that one, aren't you? Okay, Ron, thank you.
Mike Collins talking to Houston Control, bringing up his oxygen flow to pressurize the CSM to the point where the tunnel joining the two vehicles can be pressurized in preparation for removal of the hatch and stow it to the hatch and then the transfer. In about an hour and 15 minutes, the Spacecraft Commander Armstrong and Lunar Module Pilot Aldrin back to the Columbia. The Eagle is back, and Eagle is docked with the command module.
They don't really have too many great, big, tremendous earth-shaking, moon-walking type events to follow through on, do they?
You know, Frank, now that we've been through all these difficult 4 days, 5 days since last Wednesday, launched last Wednesday, and particularly since the lunar landing and the 30 straight hours we've gone here, I am weakened. I am weakened to think of what has been accomplished, because by my own checklist, they have accomplished. Armstrong, Aldrin, and Collins have done beautifully, performed beautifully, 9 of the 11 major hurdles, 9 of the 11 major rocket engine burns on this flight. From launch at Pad 39 of the Saturn V, from the translunar insertion a couple of hours later, 2 hours and 44 minutes later, to lunar orbit insertion almost 76 hours after they lifted off, to the descent orbit yesterday afternoon, the power descent initiation that took them down to a safe touchdown. That was Event 6 at Tranquility Base in the Sea of Tranquility. To that heart-shaking, heart-throbbing ascent that went so beautifully 3.5 hours ago. Through the steps of rendezvous, which may seem like old hat to those of us who have covered Gemini and the space program, but it was the first time men had lifted off the moon in rendezvous. Through the docking 4 or 5 minutes ago. The 2 major events that lie ahead of the trans-Earth insertion burn later tonight or perhaps tomorrow morning, depending on what spacecraft Commander Armstrong decides to do, elects to do. And the splashdown, Thursday about 12:45 p.m. Eastern Daylight Time. 9 of the 11 critical and dangerous events have now been done. Technology triumphs. And all I can think, Frank, is that it's that Eric Hoffer quote I used the other day, that the great genius of America is to take something momentous and make it seem unmomentous. Only in this case, it doesn't seem unmomentous to me.
No, or to anybody else, Jules, really. The astronauts have been, they have favored us with some unexpected television shows on the way up to the moon. Of course, nothing they can do can equal what we saw last night. But there will be another television show, a scheduled one, 15-minute color television, of the moon and the Earth tomorrow night at around 9 o'clock Eastern Time. It is possible, of course, that they might provide us with a show even before that, but not tonight. There will be no television from Apollo 11 tonight. They've got far too much to do, and they have done everything so very well indeed. All right, we now have a picture from Apollo 11, so let's go to Houston for the conversation between the spacecraft and Houston.
This is Apollo Control. While we're waiting for the television pictures to come in, we have in the control room here a vase full of long-stemmed red roses and a card saying, "To one and all concerned, job superbly done, from a moonstruck Canadian." Continuing to stand by as we wait for the pictures to come from Columbia. Here they come. Houston, Apollo 11, over. Roger, go ahead, 11, over. Are you picking up our TV signal? That's affirmative. We have it up on the outer 4 now. The focus is a little bit out. We see the Earth in the center of the screen. Still have a little white dot in the bottom of the camera, apparently. And see some land masses in the center. At least I guess that's what it is. It's very hazy at this time on our outer 4, over. Let me change. I believe that's where we just came from. It is, well, I'm really looking at the bad, at a bad screen here. Stand by one. Hey, you're right. Not bad enough. Not finding you on the right line on your screen now. What? It's not bad enough not finding the right landing spot. We're giving you at the right planet. I'll never live that one down. We're making it get smaller and smaller here to make sure that it really is the one we're leaving. Oh, that's enough, you guys. That was a good picture there. Okay, that's enough of the moon. Okay, that's enough of the moon, Charlie. We're getting set up now for some inside pictures. Right.
How do you read me, Charlie?
5 by now, Buzz, over.
Okay. More mundane affairs. Now that we've left the moon, I'd like to trace through a little bit for you developments that have taken place in the food department. I'm sure you've always the type of a drink container. Now, a little later, Mike will show you how the water gun operates with its new filter to take out hydrogen. Essentially, this water gun is put in this end and filled up this bag with water, and the drink then dissolves in the water, and this end of the mouth feeding. Likewise, we have other foods that are more solid nature. You can probably see this shrimp cocktail meal. This afternoon, while the two of us had salmon salad. Another early development was the use of bite-sized food.
11, Houston, Buzz, you're breaking up badly. Would you check your box, over?
Roger, how am I coming through now, Charlie?
Roger, you're very clear when you come through. It's just that your box is not keying at every word, over.
Okay. These bite-sized objects were designed to remove the problem of having so many crumbs floating around in the cabin. So they designed a particular size that would be able to go into the mouth all at once. I think since all of our experience, we've discovered that we can progress a good bit further than that back to some of the type meals that we have on Earth. As a matter of fact, on this flight, we've carried along pieces of bread. And along with the bread, we have a ham spread. And I'll show you, I hope, how easy it is to spread some ham. Environment of 0G. We've discovered that it is quite easy to all very familiar with.
Apollo 11, Houston, we noticed your roll rate increasing. Would you please see if you can bring that down to about 0 for us, so we'll be losing a high gain shortly, over.
We can also use zero gravity to demonstrate many things that we've all learned in school. I'd like to demonstrate briefly how easy it is to explain the action of a gyroscope. If I spin this can, we know that according to the equations of motion, that we would expect that if once this is given a spin and has a spin axis in this direction, if we give it a particular torque, and I'll do this by pushing my hands against it in this fashion once it's spinning, by the equations we can predict that as I put this torque on it, it will in fact rotate this direction. Let's see how well this works out. As I applied the torque this way, it rotated this way. Too close, I think.
11 Houston, it's a pretty good demonstration. Houston, this next is a little demonstration for the kids at home, all kids everywhere for that matter. I was going to show you how you drink water out of a spoon, but I'm afraid I filled the spoon too full, and if I'm not careful, I'm going to spill water right over the sides. Can you see the water slopping around in the top of the spoon, kids? That's affirmative, 11. Okay, well, as I say, I was going to show you, but I'm afraid I filled it too full, and it's going to spill over the side. I tell you what, I'll just turn this one over and get rid of the water and start all over again, okay? Okay. And you can see up here we don't know where over is. One up is as good as another. That really is water, though, I'll show you. That's really not the way we drink. We really have a water gun, which I'll show you. There's the water gun. This cylindrical thing on the end of it is a filter with several membranes. One allows water to pass, but not any gas. The other allows gas to pass, but not any water. So by routing the gaseous water, which comes from our tank, through this filter, we're enabled to drink purified water without the gas in it, filtered water. And, of course, all we do to get it started is just pull the trigger. Sort of messy. I haven't been at this very long. It's the same system that the Spaniards used to drink out of wineskins at bullfights. Only I think this is even more fun. Well, be seeing you, kids. Thank you from all the kids in the world here in the Moker who can't tell the Earth from the moon. All right, just stand by one and we'll get you that earthquake. Looks like you need a wineskin up there, Mike. That'd be nice. Okay, K11 Houston, I have a picture now. That's affirmative. I refuse to bite on this one, though. You tell us. Okay, this should be getting larger, and if it is, it's the place we're coming home to. Roger. No matter where you travel, it's always nice to get home. We concur, 11. We'll be happy to have you back.
Well, let's answer some questions here, Jules.
All right, we'll
People
take some more
have been,
questions.
Sending in questions from all over the country. Here is one from David Doler, who is 10 years old, Philadelphia, and David wants to know, do they send the LEM adrift in space after boarding Apollo? I am a science fan. I am 10 years old. The answer, David, is yes. They do send it adrift in space.
It'll orbit the moon for X number of months and then finally impact the moon at some later time.
Mrs. Thomas Fee of Edison, New Jersey writes, if any signs of other life exist, will we see it or them along with the astronauts, or have they been advised to screen out such signs if they occur, or such sights, so as not to frighten the viewing public. I don't think there's anything in the flight plan about not showing us what they see up there.
That's contingency plan 7/4-A.
I must tell you, Mrs. Speed, that I don't think the astronauts have been told not to show us anything. I think that if there's anything up there, we'll see it.
And hear about it.
Sandra Howard of Anaheim, California, would like to know, why aren't women allowed to participate in these historic events? If there is some specific reason, I would like to know it. And if not, I would like to know where to get an application. Well, you could write to Jules. Would you be able to tell her, Jules?
How to get an application? I don't know of anybody in the space program, Frank, especially any astronauts who are against having women aboard spacecraft or women in the space program. There are certain basic biological problems that have not yet been met and conquered, namely an ordinary mixed cruise.
Yeah, but I'm thinking of the fact that the Russians did.
The Russians did get Valentina Tereshkova up in one of their early spacecraft. The basic real reason is that the space agency up to now has insisted that only qualified jet test pilots could fly as astronauts until about 2 years ago when they started taking scientist astronauts and training them as pilots. And up to that point, no qualified women test pilots had applied to NASA. Otherwise, NASA would have had a hard time rejecting them. But there is every reason to think that on future flights of several years from now, that women scientists may fly aboard as astronauts.
Peter Jennings is standing by along with Tom Jarrell, and they will move in here to continue this coverage. But first, Peter is going to bring us up to date on the news of the day other than the moon landing. Good night.
In Saigon, ABC's Frank Mariano asked Vice President Win Kao-ki if the moon landing would affect the war. He said he didn't think so. He said that a more realistic problem was the war. He said that if there could only be peace, the people could devote themselves to rebuilding a country, and he would retire from politics. The tug of war over how to achieve a political peace goes on endlessly in Saigon. A central figure in that tug of war is President Thieu, and he is being pushed and pulled by powerful opposing forces. ABC's Craig Spence explains it in this report.
President Thieu is a man in the middle. On his left is the U.S. Embassy, at first suggesting, then nudging, and now pushing Thieu into compromising with the National Liberation Front. On his right is the Saigon military clique, at first agreeing, then resisting, and now opposing any compromise with the National Liberation Front. Vice President Key has become the chief spokesman of this group. It's led by the generals and backed by the rich, the Catholics, and Northerners who fled south when Ho Chi Minh took power. What Vice President Key said publicly the other day at the National War College is what this group believes privately, that the U.S. wants to sell out to the Viet Cong. Ostensibly, America spent billions of dollars in economic and military aid to build a strong government, one that would create a genuine national revolution to steal the thunder from the communists. Unfortunately, too much of our aid went not to the peasant, but to the very powers who opposed any change. The military clique did not use this aid to spread social justice and political reform, but instead to consolidate its own position, including drafting, jailing, and exiling serious dissent. Now the U.S. is in the unenviable position of having financed and strengthened its own opposition, and it's this opposition that prevents President Thieu from seriously compromising with the National Liberation Front. Craig Spence, ABC News, Saigon.
The police chief of Martha's Vineyard, Massachusetts, will file formal charges today against Senator Edward Kennedy, accusing the senator of leaving the scene of a fatal accident. In compliance with state law, Chief Dominic Arena already has sent Kennedy notice by registered mail that a complaint is being filed in the death of Mary Jo Kopechne, who was drowned early on Saturday. Kennedy, as you will probably remember, was driving Miss Kopechne to Edgartown after a dinner party when their car skidded off a bridge and landed upside down in 8 feet of water. After Chief Arena files his formal complaint, Senator Kennedy will have 24 hours in which to request a hearing. Since reporting the accident to police 10 hours after it happened, Kennedy has been in seclusion at his home on Squaw Island. In Washington, the Senate Majority Leader Mike Mansfield expressed his deep sympathy for the Kennedy family and said that he had every confidence in the senator. Senate Minority Leader Everett Dirksen declined to comment on the potential political effect of the accident. The The city of York, Pennsylvania has undergone a fourth night of racial trouble, and authorities describe the situation as chaotic. Since Thursday night, 27 people have been shot and about 30 have been arrested. Police say the trouble stemmed from a false report in which a Negro boy claimed that he had been doused with gasoline by white boys, but later admitted that he himself had been playing with lighter fluid. National Guardsmen sent in to stop civil disorders in Youngstown, Ohio, were withdrawn last night. The east side slum area of the steel town erupted into a near riot last Wednesday night when a store owner claimed maltreatment by police. The city was reported quiet as 150 of the National Guardsmen left. The nation's air traffic would come to nearly a complete halt next week if the air traffic controllers carry out their latest threat. A spokesman for their organization says 3,000 controllers, nearly half of the 7,200 working in the nation, will resign after Apollo 11 returns to Earth. Their action would be in response to a government plan to punish controllers who took part in last month's slowdown at major U.S. jet ports. The FAA announced on Friday that it had planned disciplinary action against those controllers who called in sick during the slowdown. Unless the FAA withdraws its threat, all commercial flights could be grounded. One airplane not affected by a U.S. slowdown or even a shutdown is Air Force One. It will be overseas with the president on his coming world tour. And at least one new airport is on the plane's itinerary. ABC's George Watson reports from Bucharest.
On this spot at 12:15 on Saturday, August 2nd, President Nixon is going to arrive, the first time an American president has visited a communist country in 25 years. The only problem is the airport hasn't really been built yet. The old Bucharest airport is not big enough for the big jets, so about 3 years ago, construction started here on a modern new jetport. It was due to be finished in 1971. But then President Nixon's trip was announced, and on top of that, the Romanian Communist Party is holding its Congress next month. So work was speeded up, and right now there are 2,000 Romanians working around the clock to finish the job, or at least to make it presentable for the president. Even the troops have been called out. Battalions of Romanian soldiers are attacking the construction chores. They can't possibly finish the whole job by August 2nd, so they are concentrating on completing a VIP lounge. Romania claims to be building a classless communist society, but it's not apparent here. At least some travelers will be more equal than others. After Comrade Ceausescu greets Mr. Nixon, they will go into this room. When it's finished, it will boast marble floors, velvet walls, and crystal chandeliers, fit for a king, even a president. At least that's the plan. The optimistic officials in charge of this project confidently predict that everything will be ready and waiting when President Ceausescu meets President Nixon. That's 12:15 on Saturday, August 2nd. This is George Watson, ABC News, Bucharest.
That is the non-space news, as some distinguished writer called it. The Earth news, anyway. Thomas?
Peter, generally, of course, everyone is claiming to the heavens this space feat, but naturally you can't please all the people all the time. And at Meridian, Connecticut, a man called the newspaper there, the Morning Record, complained that he had looked all over his radio and his television dial, and he couldn't find a single baseball game. All he could find was something about men going to the moon, and he thought it was just a lot of nonsense. Fortunately, not many people think that way.
Must have been a Mets fan.
It's very tempting, of course, to speculate about going beyond the moon, further into space. The flight of Apollo 11, like earlier experiments, can certainly lead to more important developments very close to home, other than going deeper into space. The supposedly hostile environment of space has certain unexpected uses, which scientists hope to put to work. A whole series of projects on this order is now being worked out, generally referred to as the orbiting space stations. This was the subject of the program in the ABC television series Discovery, with Bill Owens reporting. Let's look at that now.
Where do we go after the moon? One of the suggestions for the future is to have a self-contained orbiting space station that could be sent aloft and positioned anywhere we wanted it. Here's a model of a proposed space station that could fit into the same Saturn rocket that carries the Apollo spacecraft. After being placed into orbit and separated from the rocket,
the arms of the station would automatically unfold and lock together in the shape of a wheel. Fully extended, it would be 150 feet in diameter. Small rocket motors would impart enough spin to give the station an artificial gravity. Such a station would serve as a manned laboratory, performing experiments and scientific observations impossible from an Earth base. It could serve as a docking station for refueling and maintenance of other spacecraft, and a command and control center for more distant voyages, like a trip to Mars or Venus.
Cryogenics, I am assured by those in a position to know, is a science which is very vital to the Apollo space program. We have in our studio a couple of gentlemen who are qualified to talk at length about cryogenics. First of all, our commentator is Don Blake, or rather our demonstrator is Don Blake, and this is Edward McCandless, who will be our commentator on the question of, would you pronounce it for us and tell us what it is to begin, for those still struggling for the first cup of coffee this morning, gentlemen?
Yes, I would say that cryogenics is the science of cold, and the science of cold has been used to produce these cryogenic fluids, which Don is going to demonstrate in some rather simple experiments. This particular flask contains liquid nitrogen, which is the principal constituent of the air, as you know. This material, in its cryogenic form, is very much like water, as you can see. I should say more accurately, it's like boiling water. But it is at a very low temperature, about 320 degrees Fahrenheit below zero. At these very low temperatures, things really happen to materials. Don has dipped the carnation in liquid nitrogen, and you can see that something very unexpected happened. This phenomena of the change of physical properties of materials as they are refrigerated to the very low temperatures that exist in space, and which exist, of course, in the cryogenic fluids in the Saturn vehicle, presents a great materials problem. And the question of getting materials that will stand up under cold and satisfactorily handle the cryogenic fluids has been a very important one, but has been well solved. Just to give you an idea of what these problems are, Don is forcing liquid nitrogen from the flask through a piece of ordinary rubber tubing. The tubing dips down into the liquid nitrogen. As it goes through, it freezes the tubing and produces a very brittle material out of what is ordinarily considered to be a very soft, pliable material. Don will further demonstrate this by dipping a piece of, again, ordinary gum tubing into liquid nitrogen. And Don, if you may be able to break that. Again, it doesn't sound much like rubber tubing as we know it. There is a second very important cryogenic fluid aboard the Saturn vehicle, and that is liquid hydrogen. Whereas liquid nitrogen is very convenient to demonstrate in the studio, we of course wouldn't do this with liquid hydrogen. Liquid hydrogen, again, looks very much like liquid nitrogen, but it has two important differences. First of all, it is a very energetic fuel. It possesses about 3 times the chemical energy content of gasoline when burned, and for that reason is a very desirable space fuel. But it has a further disadvantage, that it is very bulky, whereas this liquid nitrogen and also liquid oxygen, which are used as the, like liquid oxygen, which is the oxidizer on the Saturn booster stages, liquid hydrogen is very, very bulky, having a density of only about a 15th of that of water or liquid oxygen. And as you notice in the Saturn vehicle, the liquid hydrogen tanks are very, very bulky. Another effect that cryogenics, or very low temperatures, has on gases is to shrink them. And Don has blown up some balloons with his own breath, and when he puts them in liquid nitrogen, the gases shrink down, and finally liquefy, because air will liquefy at liquid nitrogen temperatures. Now, when the balloon begins to pick up heat from the atmosphere here in the studio, the gas is warmed, and it produces just about the same volume as it had in the first place, and these balloons will return to their original condition. Don may have a little bit of a trouble getting that out of his pocket.
Mr. McChandler?
Yes.
The main purpose for this, then, is in the development of rocket fuels, as I understand it.
Yes, because cryogenic fluids are compact, it turns out that the cryogenic liquid form of oxygen and hydrogen is the only way in which the required quantities of these gases can be put aboard a Saturn vehicle. If we had to take them on the Saturn vehicle in the heavy steel tanks that you see in garages and hospitals, you would find that the Saturn vehicle is thousands of tons overweight and, of course, would never fly. Don is showing here that as the gases boil off, as you see it boiling in this flask, there is a great expansion going on, and the gas will create pressure. This, again, is a problem that has to be handled in the design of the space vehicle. But again, satisfactory techniques have been worked out, and cryogenic fluids have become, you might say, the workhorse of the Saturn program.
Peter, the moon, of course, has always delighted and fascinated mankind since almost the first night man saw it, and he has coveted it. It has stirred the imagination of many people and all types of speculation about what it is and who lives on it. ABC's correspondent Bill Buttell in London talked to one of Britain's knowledgeable experts on astronomy and on space, the popular commentator Patrick Moore. Buttell asked Moore, why have men always wanted the moon?
Well, I think, you know, that as soon as men realized that the moon really is another world, it was logical to talk about going there. But when we go back 2,000 years, this is Lucian of Samosata, the first science fiction writer in history, well, it wasn't really science as we know it. He had an idea, which he wrote forward in his book called The True History. And he called it The True History because, in his own words, it was made up of nothing but lies from beginning to end. And in this book, he had a party of sailors going through the Pillars of Hercules, the things we now call the Straits of Gibraltar, and their ship was caught up in a waterspout and hurled upward so violently that it kept on keeping on for 7 days and 7 nights until it finally landed on the moon. And that was his method of space travel. And when they got there, the sailors found they'd arrived at a fascinating time, because the King of the Moon was about to have a war against the King of the Sun with regard to who should have first rights on Venus, the planet, not the goddess.
Well, now, the very idea, the very conception of what the moon was interesting in the early days of man's history, wasn't it?
Yes, well, Plutarch had the right idea there a very long time ago, and he said that the moon is earthy with mountains and ravines, and of course he was perfectly right on this. And really, his idea of the moon isn't so very different from our modern idea.
Mm-hmm. Now, he said it was earthy. You mean like the Earth?
Well, he thought it was more like the Earth than it actually is. The whole point is, surely, that the great difference between the moon and the Earth is that the moon has, to all intents and purposes, no atmosphere. And if you have no atmosphere, you can't have life as we know it. And this, of course, is a thing that the old people just didn't realize and had no real means of finding out. This is a fairly modern development, dating back only a few centuries.
Now, who was it who said that the moon seemed to him to be in the diameter of something like a foot?
Oh, this goes back to the old Greeks, right in the very early days. Mind you, there's some people who still believe that. There's still an International Flat Earth Society, and they believe that the moon is only a few feet in diameter and shaped rather like a saucepan.
Yeah. Well, this was one of the first attempts to understand the moon, wasn't it? At least in recorded history.
Yes, I suppose it was. But after all, you couldn't really find out a great deal about the moon until telescopes came along, and that was in the very early part of the 17th century. And as soon as you got telescopes, then, of course, you could start to find out something about the moon's actual nature. And we had science fiction stories then, too. There was one in the early part of the 17th century, written by an English bishop, Godwin.
Yes.
And this is a fascinating story, because in his novel, the hero, Domingo Gonzalez, is marooned on a desert island, and he makes up his mind to escape. And the only way he can think of doing it is to build a raft and then teach ganzers, or wild geese, to tow him through the air. And this was duly going on one day, and he was being towed through the air on this raft, when he suddenly made the entertaining discovery that the ganzers hibernated on the moon and were very busy going there, taking him with them.
Yes, this was the picture of the ganzers taking him, wasn't it?
The ganzers taking Domingo Gonzalez to the moon. A very nice idea, but I don't think it's going to work.
Well, who was it who first began to talk about the moon in anything like realistic modern terms? Was it Galileo or Copernicus?
Not Copernicus, certainly. He was in the pre-telescopic era. No, I think we must say Galileo, although in fact, you know, the very first moon map wasn't drawn by Galileo at all. It was drawn by an Englishman, Aeolus, who was tutor to Sir Walter Raleigh at one stage. And he produced a telescopic map of the moon before Galileo did. But certainly, so far as sheer concentrated observation and interpretation goes, in those very early days of telescopic research, Galileo stands alone.
Well, I was fascinated by some of the ways that people in their fantasy talked about going to the moon. What was the story of the man who was going to, Cyrano de Bergerac it was, wasn't it, who was going to strap dew bottles to his body?
This was a lovely idea. He had a very nice means of space travel. He worked it out like this. If you go out in the early morning and look at the grass, you will see that it's covered with dew. Well, if you go out a few hours later when the sun has risen, you will find that the dew has disappeared, and so presumably the sun has sucked it up. So according to Cyrano, if you want to go into space in one easy lesson, all you need do is to collect a lot of bottles, fill them with dew, fasten them round yourself upside down, stand out in the morning, and let the sun do the rest.
And up you'd go.
Well, I haven't tried this myself. I think I'd need an awful lot of dew.
Yes, well, what I'm interested in, too, one of the things that fascinates me, because I really am a layman when it comes to talking about going to the moon, or really when it comes to talking about space or anything of the sort. I'm fascinated by the accuracy, the almost primitive accuracy that some of the early scientists, or maybe even just quasi-scientists, came up with in their ideas about the moon.
Well, of course, the first real scientific novelist of what we can call the modern era was, I suppose, Jules Verne, and his famous book From the Earth to the Moon, which came out in 1865. And he wasn't a scientist himself, but he knew plenty of people who were, and he got his facts right as far as he could. But, of course, he did make one fundamental mistake. His method of propulsion to send a projectile from the Earth to the Moon was by means of a bullet fired out of a space gun. And this, of course, just isn't going to work. I mean, there are two very good reasons why it won't. First of all, air sets up resistance, and resistance causes heat. And if you fire a bullet through the lower atmosphere at a speed of 7 miles a second, which is the speed you've got to go if you're going to break free from the Earth, well, you're going to set up so much heat by friction that you're going to turn into a puff of smoke. So that's one reason why the space gun doesn't work. And, of course, there's the extra point that even if you forget that one, if you forget about air resistance entirely, and just imagine that you sit yourself inside a space bullet and then get yourself fired up at 7 miles a second, escape velocity, well, it's going to be quite a jerk, isn't it?
Yes.
And I think that anyone who tried that, well, might, I suppose, get to the moon, but would certainly get there in the form of fine jelly spread about inside his projectile.
Yes, well, Jules Verne, admittedly, and in your book you point out that his theories were all wrong, except there is a very interesting picture that you have in your book. It shows the landing in Jules Verne's book, the landing of the space capsule that he had there, a projectile landing in the middle of the ocean, and here it is with an American flag on it, and some people in a whaleboat are circling around, and it looks for all the world very much like the space capsule that we pick up in the Pacific or the Atlantic Ocean, doesn't
Well,
it?
there was a great deal that Jules Verne did get right. I think the only thing he really got wrong was his basic method of propulsion. If he'd used rockets instead of the space gun, he would have been uncannily accurate. After all, he even got as far as suggesting building a 120-inch telescope on long peaks, especially to observe this space shot. And after all, that's not so very different from the Palomar telescope of today. And he even got his landing site right.
Yes.
Because his Stones Hill is not so very far from Cape Kennedy. And
Yes, his launching site, you mean?
Yes, his launching site.
Yes.
And his splashdown area was right, too. No, I think if you forget the fact that he used the wrong method of propulsion, and he got some facts wrong about weightlessness, if you forget those two, he's uncannily accurate.
For any of you living in New York City, yesterday, you will probably have had the opportunity to see one of a dozen or so space movies that were run in their entirety, fairly modern space movies, made in the 1950s. And every station, I suspect, across the country that has had some kind of old television library that has a space movie in it has had a chance to run it. I had a pretty good opportunity the other day to spend some time with Dick Schickel, who is the film critic from Life magazine, and Dick hied me away to a screening room, and we looked at a great mass of material of films that have been made about space since really around the turn of the century. It's well known, for example, that Germany was an early starter in the art of rocketry, but perhaps less well known is the fact that they were also one of the first countries, one of the first peoples, to start making movies about space. And Dick Schickel and I sat and looked in this particular segment at a very interesting picture that was made in Germany, and Dick will explain it in somewhat greater detail. Burdened as we have been by technical detail over the last few days, Dick Schickel and I have been sneaking off to screening rooms to look at old movies about what people in earlier periods thought about what was going to happen today. We're going to show you a film now, which is a 1929 German film called Woman in the Moon. What's interesting about this film, as Dick will expand on, is it's a really very serious attempt to picture what it might be like if man went to the moon. It's technical. They had technical advisors in those days. It's very amusing. With T.K. Obert, Hermann Obert, who later became, he was a great German rocketry expert, and he later became Werner von Braun's teacher. So technically, 1929, it has a specific look to it. Dramatically, how about that?
Dramatically, it's pretty absurd, I think. But it was directed by the great Fritz Lang, and most people remember him for M, which made Peter Lorre a star, and was probably the first realistic film about a criminal psychopath and a landmark in film history. But The Woman in the Moon was really closer to the main line of Lang's interests and the German industry at that time. They were very hung up on fables and nightmares and fantasy, and he was a great explorer of these kind of weird visions. So, though most of the people on this voyage couldn't pass the psychological tests at NASA, I think the important thing he's driving at is this is a fable, a parable, about man's greed, really. Now, this is a scientist who was obsessed with the notion that there's gold in those lunar hills.
These are what, potential backers?
No, these are scientists he's explaining the idea to, and like all great ideas, it's scoffed at and scorned.
For scientists have never been as obsessed with gold as backers have.
Now, this is a backer's audition. It's 30 years later. And the old man's been very mad, but his cause has been taken up by younger people. And it's a mock-up of their rocket ship.
You pointed out once before, Dick, it's really worth noting here that space adventure and going to the moon or Mars in those days, the moon in this case, was a private venture rather than a government.
That's right. Nobody thought governments had enough imagination to do it. They were depending on private capital. Checkbook.
This is amazingly realistic and looks very contemporary.
Doesn't it? There's an early Shorty Powers.
Or Jules Burton. Here, too, about water. You'll probably recall when Saturn V went up this time, there was enormous water to cool the pad down, and in these days, they saw water as a means by which to launch the rocket out of.
Well, to keep it upright so they could get it launched. They drew a pretty good crowd for space shoots even then.
And the first countdown.
As you can see, it's a kind of a mixed crew there.
Fascinating here is that they understood that it was going to take 2 stages at least to get to the moon. little trouble igniting the second one.
That's right. He's having his problems there. Again, because he has to do it mechanically.
Stage separation. Ah, fantastic.
And now here's a kind of a nice solution to the problem of weightlessness, which will be familiar to any subway rider.
And apparently on this trip, Woman in the Moon, we had a stowaway.
That's right.
No good film without a stowaway.
He came on carrying science fiction magazines to read on the trip. I think it's probably worth pointing out that technically, the studio that made this, which was the UFA studio in Berlin, was really probably technically the most advanced movie studio in the world. It was really marvelous special effects people there.
Again, the problem of weightlessness. The Dick is where Herman Obert's technical advice goes out the window altogether.
Pretty much, yeah.
They're in the moon gravity now.
They brought along that scientist we saw at the beginning there. Now there's Obert predicting moon dust. You can't even see the capsule. It's buried so deeply in it. This is our gold-obsessed old party here.
What you should be watching for here, by the way, are a couple of contradictions. Look first at the match. There is no atmosphere on the moon as we know it, and yet our scientist discovers it. And
yeah, you can even do that with a match on the Earth. You know?
And secondly, look at the boots, which are terribly similar to what are worn today.
To look for water, but he's going to use it to work out his obsession, which is his gold.
It was pointed out by a scientist just the other day that if there is gold on the moon, the cost of going and getting it and bringing it back would make it so many times its Earth value that it wouldn't be worth it. But it's amazing in that film to see the combination of accuracy and poetics.
That's true, and I think the most important thing to remember about these movies is that they are visionary. They do speak to our most attractive quality, I think, which is man the visionary. And I think that's what's most important about them, not whether they're technically accurate or not.
It's unlikely that's going to play in your neighborhood in the next little while, but it is called Woman in the Moon if it ever comes around. Thanks again, Dick Schickel from Life.
Thank you, Pete.
Good morning. I'm ABC Science Editor Jules Bergman, and with me is ABC White House correspondent Tom Jarrell. Apollo 11 is now 14,000 miles out from Earth, speeding homeward at 11,000 miles an hour to end its epic 8-day lunar flight. It's headed toward a landing 950 miles southwest of Hawaii. The weather, good generally, but windy, up to 21 miles an hour, with seas running to 6 feet. Astronauts Neil Armstrong, Buzz Aldrin, and Mike Collins may be a bit uncomfortable in that rolling sea state while they're waiting for the helicopters to pick them up and take them to the prime recovery vessel, the aircraft carrier Hornet, now standing by in the recovery area after having moved that recovery area and the ships 215 miles northwestward during the night to avoid thunderstorms and high seas. It's going to be a most unusual recovery, one complete with the President of the United States. And to give us that story, Tom.
Jules, the President is now on the communication ship Arlington. He'll be flying by chopper shortly to the deck of the Hornet. There, he will become the first chief executive to personally be on hand to welcome astronauts back from outer space and be involved in a small footnote to history, something the President so frequently likes to refer to. The President will be using this successful Apollo mission as a springboard for an Earth orbital trip of his own. After splashdown today, he will begin a 10-day goodwill trip that will take him through 5 South Asian countries, a brief journey behind the Iron Curtain to visit with leaders of Romania, then a stop in England for an airport conference with Prime Minister Wilson, returning to Washington Sunday, August 3rd. By traveling in the wake of the Apollo 11 success, the President is assured of being abroad at a time when United States prestige will be extremely high, possibly at an all-time high for recent years. It's a very nice asset when you're on such a diplomatic journey. By the way, the President was a naval officer during World War II, but last night on the Arlington was the first time that he had ever spent the night on a Navy ship. Of course, the major attention today is not on the President, but on the astronauts. How are they doing, Jules?
Tom, they're doing just fine. They have the spacecraft configured for the reentry. They sound relaxed and rested this morning and ready to come home after that epic 8-day lunar flight. Now, here's what happens this morning, beginning about 55 minutes from now. The spacecraft soars in over the southern hemisphere and then plunges west to east over Australia until it finally hits the splashdown area and comes down to a good landing 950 miles southwest of Hawaii. We'll give you another idea of that now. That's the way our telestrator can do dotted lines. Now, we're going to show you what happens as the spacecraft encounters the Earth's atmosphere. You remember the Earth's atmosphere is a belt that extends for about 400,000 feet over the Earth like that. The spacecraft has to fly in precisely at a 6.5-degree flight path angle, rather like that. And here's the dangers involved in this procedure. If the spacecraft re-enters too steeply, it'll plunge into the atmosphere, burn up and break up, and the astronauts would be lost. On the other hand, if the command module computer or the astronauts fly too shallow a re-entry angle, they would skip off the atmosphere like that and go out 10 or 20,000 miles, and they'd run out of oxygen and batteries and also be in trouble. What we're shooting for, to show you again, what Armstrong, Aldrin, and Collins will be doing with their computer guiding them is to fly back in at the 6.5-degree re-entry angle, or flight path angle, we should say, which will carry them back in like that and like that in a gentle looping maneuver until they finally come to a landing 950 miles southwest of Hawaii, like that. And now we'll show you the actual re-entry corridor over the Earth with this map. Here's Australia. Here's Australia here in the southwest. There's Hawaii up here, the upper end of our quadrant. The spacecraft comes in, flying west to east over Australia, loops up gently like that, and finally loops forward to come to a landing right here. We're a little bit east of our target. Let's try that again. We ran a wild with ourselves there. West to east over Australia, comes into a looping landing like here, about 950 miles south of Hawaii. The interesting thing that happened in the last 8 to 9 hours is that due to the bad weather, the reentry area was moved. The entire task force, the recovery carrier Hornet, the communication ship Arlington, above which President Nixon is presently on, and the escorting destroyers steamed at flank speed some 215 miles north from their old position, which was relatively like that. That was the original splashdown area. They steamed 215 miles north to a new splashdown position there to get calmer seas and less winds and better reentry and recovery weather for the astronauts. We'll give you an idea of what happens here during the actual reentry process. Apollo is protected, of course, by a heat shield. This is an idea of what it looks like. It's a aluminum honeycomb with phenolic resin that's actually injected into it. The heat shield varies in thickness from 1.5 inches, as it is here, down to about 5/8 of an inch. The thicker portions, of course, are where the heat is most intense, where the astronauts face heats of up to 5,000 degrees. And it's a heat shield that works darn effectively. We're going to show you how effectively right now. As we turn on
this trusty blowtorch and hope we don't blow ourselves up. And this is a little bit of what happens during the reentry process. As some of you may remember, during the Apollo 10 reentry, that flaming fireball over the Pacific, as seen from the recovery carrier, this is what the sailors below and television viewers were actually seeing. It was the heat shield charring and ablating during the 25,000-mile-an-hour reentry speed as the heat shield heated up to 5,000 degrees. And there you can see the way the phenolic resin is injected into the honeycomb slots here. The heat shield material actually chars and ablates away, producing a radiator effect. The burning away of the material keeps the astronauts inside the spacecraft at a cool, comfortable 75 degrees. If there were no heat shield, it would be a bad day indeed. They'd be singed terribly by the heat. It would be impossibly hot inside the cockpit. The heat shield glows green, red, and white during the reentry process. Our torch reaches only about 2,000 degrees Fahrenheit. You can imagine what it's like at the 5,000-degree reentry speed. Soaring back in at speed, reaching 25,000 miles an hour. Let's go to Apollo control for late word.
System is go aboard the spacecraft.
That word was communication system is go aboard the spacecraft for reentry.
Apollo 11, Houston, we see you getting ready for SEP. Everything looks mighty fine down here.
Same here, Ron. Thank you.
SEP, separation of the command module and service module, 15 minutes before reentry, 2,000 miles out from Earth. Separation takes place, the astronauts will cant the spacecraft around a bit so that when they use their little reaction control thrusters to pull away from the service module, it's harmlessly out of their way. And I think the apprehension, Tom, in mission control is readily apparent now, though they're hearing good radio signal from Apollo 11 via the Australian tracking stations. Part of the fun of the mission for them, part of the history and the climax of it is seeing it on television, live, as it were, courtesy of television, and seeing the actual reentry, if we're lucky, and the splashdown and the recovery of the astronauts. Now, here's separation, as we'll see in about a few minutes from now. It should take place with the spacecraft. The service module pulls away on its own. Then the command module is tilted down toward the Earth's atmosphere. That actually happens automatically with one of the CMC or the command module computer programs taking over. The astronauts back it up manually.
We're awaiting confirmation of separation.
Jack Riley and Apollo control. Separation should have taken place.
We confirm separation now from on the ground readings from telemetry. We can confirm separation.
That's one of the three critical parts of the reentry process. The service module is now safely away from Apollo 11. Now it's tilted down, as we see in our animation, to face the steering reentry heat.
During a conversation this morning earlier between Mission Control and Mike Collins and Apollo 11, Mission Control assured the astronauts the carrier Hornet is on station just far enough off the target point to keep from being hit. They feel very confident about this.
Well, if Apollo 11 is as accurate in its aiming point as Apollo 10 and 8 were, it should be very close. They landed almost too close.
Apollo 11, Houston, you're still looking mighty fine here. You're cleared for landing.
Capcom, Ron.
Yeah, we appreciate that, Ron. Thanks.
Right, gears down and locked. Roger.
For a pilot, that must be a terribly reassuring phrase. You are cleared for landing after coming back from the moon.
And at this point, both speeds and heat on the spacecraft are beginning to build up.
800 nautical miles high. Velocity 33,000 feet per second.
They're around 7 minutes away from reaching 400,000 feet above the Earth.
the really critical point of this reentry, where they encounter maximum speed and maximum aerodynamic forces and heating effects.
Guidance reports Apollo 11 right down the middle of the corridor. 7 minutes away from entry.
From all those signs, it looks like Apollo 11 will be a record-setting closeness, have a record-setting closeness to the Hornet. The actual landing zone, Apollo 11 heading for about 950 miles southwest of Hawaii. With a Hornet, 38,000-ton carrier, a tired veteran of World War II, built in 1942, is standing by on station to pick them up.
Our space down here, our latitude, longitude, 1330, 16915. That's, Hornet, right out.
This is Neil Armstrong talking directly to the Hornet's flag plot room, telling exactly where he's going to land, a most unusual event. And they are very close to being on the money. We're trying to plot the coordinates Neil was reading off his computer on one of our charts here. But it looks quite close to the nominal landing area.
Hornet reports spacecraft right on target point.
Okay, Hornet, Apollo 11, now.
Don't shoot.
Now about 58 seconds away from landing.
S-1 has clear contact 150 holding.
Apollo 11 descending through clouds at about 2,000 feet.
Roger up. Hornet, roger, copy out.
That's Neil Armstrong giving the position reports.
Hornet, roger. Roger, this is Swim 1, Apollo 11.
Here is the president, of course, watching from his vantage point, some 5 decks up on the carrier, standing there with the various VIPs. The men on the Hornet, some 2,200 of them, the crew, they were up as early as 2 o'clock this morning, getting everything ship-shape, final preparations for the president, Secretary of State Rogers, Admiral McCain, commander of all the U.S. forces in the Pacific, all here to observe this historic moment.
And we're now getting word from swim helicopters, the rescue helicopters, that the crew is in excellent condition. Let's go to them now and see if we can pick up some direct radio communication.
The ship is 2¼ miles from the spacecraft now, and the spacecraft pretty clear now in the picture. The big swimmer, Lieutenant Heidelberg, is using hand signals to communicate with the astronauts inside their spacecraft. He does have a little plastic board with him and a grease pencil, which he can write on and flash messages to them that way.
Actually, Ron, not much communication is needed between the astronauts. The hatch is now open. We have word from the scene from the recovery helicopter. And the first astronaut is coming out.
That would be Buzz Aldrin, wouldn't it, Nellis?
I believe so, yes.
band on the deck strikes up.
Let's listen to that band, as they say. Presidents applauding as they play Columbia, the Gem of the Ocean. Columbia, of course, is that module out there.
There goes the first astronaut. Up in the Billy Pugh net.
Up in the Billy Pugh net.
Instructions in the helicopter, the two crew members in back, not to touch the astronaut. Dr. Carpentier will help the astronaut out of his net.
We understand that President Nixon requested that the band play Columbia, Gem of the Ocean.
Leave the flight deck.
Written on the bottom of the helicopter is another welcome aboard for the astronauts. It says, "Hail Columbia." The other night, that helicopter was on the deck, and I peeked underneath, and they had the old sign from the Apollo 10 recovery saying, "Hello there, Charlie Brown." But at the last minute, they painted the new welcome on saying, "Hail Columbia." So when the astronaut rides up in the net and looks up, he sees it painted on the bottom of helicopter 66. There goes the second astronaut up in the net.
Down here on the John Hirosaki, the NASA project engineer, who had a lot to do with developing the mobile quarantine facility, has been spending most of his time the last 5 days inside it, along with Dr. Carpentier. And John Hirosaki is a busy man right now. He's making his very, very final preparations in these final minutes before the astronauts come on board the Hornet.
It's been about an hour exactly, Dallas, since splashdown, and one more astronaut to go. So it looks like they've beaten the timetable by about 18 or 19 minutes and are just about doing it in exactly the same time it took during the dress rehearsal the other day. And considering that the spacecraft came down fairly far from the ship, the seas are a bit rough today, and they had to go through the decontamination process. That's pretty good time.
I'd say it's excellent time. You know, actually, Ron, I think that they didn't spend as much time on decontamination as they have in some of the simulated recoveries we've watched. It seemed to me it went very fast.
We're waiting now for the third and last astronaut to be pulled up to the helicopter. Then they'll come aboard. There won't be that flight deck welcome ceremony with the red carpet. There he goes. Last astronaut going up. There won't be the flight deck welcome ceremony because they've got to go right into quarantine.
However, Ron, there will be a ceremony down here on the hangar deck. The Marines will present military honors. The Navy band will move down here from the flight deck where it is right now. The President will be appearing very soon after the astronauts finish their initial medical inspection, so that the routine flight deck ceremony, which has become so familiar over the past few years, will actually be supplanted by something a good deal more spectacular down here on the hangar deck. After all, this is the first time in history that the President of the United States has been on board the recovery carrier to greet the returning astronauts.
The President has a overhang on that bridge, so he's not getting wet.
We believe the President may have moved off the bridge, possibly on his way down. It's only a very short trip. Oh, there he is. He's moved aft. And he's back to the Admiral's Bridge, just outside Flag Plot. There's 66 coming in. Land by elevator 2 for its descent. No baseball caps this time, and no handshakes. These astronauts headed for weeks of isolation. Fantastic event. Papa Canito, Ohio. Man from Montclair, New Jersey. Walk on
Oh, and here goes helicopter 66 down to the hangar deck, where the mobile quarantine facility awaits astronauts Neil Armstrong, Buzz Aldrin, and Mike Collins. And let's get the report from the hangar deck now.
Big moment. Number 3 elevator on the port side is still in the raised position. No, it's down now. Down now. I couldn't see from my point. It's now down, and the tractor is being moved back to haul the helicopter off the number 2 elevator and back here to its position alongside the mobile quarantine facility. Band still playing joyously up on the flight deck.
President Nixon is still on the flag bridge. We expect he'll be coming down soon.
Here comes the number 66 being hauled inboard from number 2 elevator very slowly by the tractor. The procedure is for the tractor to pull it straight across the ship, and it will then be backed by the tractor. So it's being pulled now with the nose forward in order to move it around in the correct position. There it goes. Now the tail of number 66 is pointing aft along the hangar deck. Astronauts still inside. They're holding the tail back. Lavalier microphones around their necks, and anything they say will be carried by loudspeaker. Large numbers of sailors behind the lines, standing there, waiting to watch this historic moment, the first appearance of the astronauts before anybody but the swimmers and the crew of number 66 telephone. Dr. Don Stoughton walking along the blue path. He's the chief of the NASA recovery team on board. Talking now with John Stonecipher, the assistant chief. Helicopter being moved slowly back here with the flight deck crew in yellow jerseys. Man up the head about to blow the whistle for it to stop. The hatch is just about in position. A few more feet. There it goes. That's it. Dr. Stoughton, Dr. Stonecipher personally moved the flight of wooden steps up to the hatch on the starboard side of the helicopter. Dr. Carpentier slides it open, and here they come. Here they come, the 3 astronauts, Armstrong, Aldrin, and Collins, waving to the crowd of cheering sailors, moving swiftly into the mobile quarantine facility.
There's a wild scene of exultation and joy and mission control as they saw, even as you did, astronauts Armstrong, Aldrin, and Collins emerge in good shape from helicopter 66 to enter the mobile quarantine facility. The pent-up emotions of 8 years of work to achieve this moment are overflowing.
Jules Dallas Townsend is now talking to the helicopter pilot, the man who was flying number 66 when they picked him up. Let's hear it.
It was a real team effort, as you know. A lot of people supported us up till the minute of pickup, and it went very, very well.
What was your total time, Don?
Gee, I'd have to look at the log sheet, Dallas. I don't know, but I feel we're about 5 or 6 minutes ahead of our schedule. It just couldn't have gone more smoothly. Chief Wood here did a magnificent job, and Chief Robnett, who is still locked up in the airplane, also did well.
Chief Wood, did you have a chance to say anything to the astronauts? Did they say anything to you?
No, sir. With the bigs on, they couldn't have heard me, and with the headset we had on, I couldn't hear anything they said. Their actions indicated they were cheerful all the way way through the entire procedure. Was there any sort of message that they conveyed in some way or other to you? No, sir. We didn't really have time. We were too busy trying to get our gear together to get back on board.
Lieutenant Johnson, you probably got a look at them. You were flying co-pilot.
Yes, I was. I looked back as we got out of the helicopter, and one of them gave me a thumbs up. That's the only signal I got from them. They sure looked cheerful, though. Glad to get back. Boy, it's a big thrill for me to pick them up, too.
Let's go outside Mission Control now, where ABC's Jim Kincaid is standing by with lunar module pilot Gene Cernan from Apollo 10.
How about it?
Pretty great. Just outstandingly beautiful. It's just unbelievable, but real.
Now, you're not entirely unfamiliar with moon flights, so I wonder if there's anything you saw on this one that really surprised you.
No, I think I sort of lived the flight with these guys through television. I felt like I was in a spacecraft, and having been there, I knew what they were thinking when they were going through. Except, of course, those last few minutes. And here's another man who's been there, Bill Anders.
Bill Anders. I talked to you just the other day, Bill. What's your first comment?
I think it was mighty beautiful flight. Really impressed. It's more than just an exciting achievement. I think it's a real reward, and it's a real accomplishment of the entire 200 million people in this country. A lot of people dedicated themselves, dedicated their ambitions and efforts, and it's not the people here in Mission Control, it's not the three guys who flew it. It's the culmination of really the sincere efforts of so many million Americans, and I think they've got a right to be proud, and I know they all are proud.
Now let's go back to the Hornet. And there's Dr. Henry Kissinger, the President's security aide, Tom?
Yes, and Secretary of State William Rogers in the foreground.
And Frank Borman in the background. And so the President obviously must be expected momentarily.
This is the scene we're familiar with, yes. Just before he arrives, usually his aides come first. Bob Haldeman, the man with the brush haircut, standing behind Dr. Kissinger. Secretary of State Rogers chatting with someone in the foreground, looks like one of the technicians.
Here comes the President now, Tom.
Through the hatch to the hangar deck. Waffle flourishes. Waving to the astronauts. The curtains have been drawn. And there they are in the rear window. President signaling for applause from the crowd. Astronauts gather in the window.
Neil, Buzz, and Mike, I want you to know that I think I'm the luckiest man in the world. And I say this not only because I have the honor to be President of the United States, but particularly because I have the privilege of speaking for so many and welcoming you back to Earth. I can tell you about all the messages we've received in Washington. Over 100 foreign governments, emperors and presidents and prime ministers and kings have sent the most warm messages that we've ever received. They represent over 2 billion people on this earth, all of them who have had the opportunity through television to see what you have done. And then I also bring you messages from members of the Cabinet and members of the Senate and members of the House and the Space Agency, from the streets of San Francisco, where people stopped me a few days ago, and you all love that city, I know, as I do. But most important, I had a telephone call yesterday. The toll wasn't, incidentally, as great as the one I made to you fellows on the moon. I made that collect, incidentally, in case you didn't know. But I called three, in my view, three of the greatest ladies and most courageous ladies in the whole world today, your wives. And from Jan and Joan and Pat, I bring their love and their congratulations. We think it's just wonderful that they could have participated, at least through television, in this return. We're only sorry they couldn't be here. And also, I've got to let you in a little secret. I made a date with them. I invited them to dinner on the 13th of August, right after you come out of quarantine. It will be a state dinner held in Los Angeles. The governors of all the 50 states will be there, the ambassadors, others from around the world and in America. And they told me that you would come too. And all I want to know, will you come? We want to honor you then.
I'll do anything you say, Mr. President. Anytime.
One question I think that all of us would like to ask, as we saw you bouncing around in that boat out there, I wonder if that wasn't the hardest part of the journey. Was that the only, did any of you get seasick?
No, we didn't, and it was one of the harder parts, but it was one of the most pleasant, we can assure you.
Yeah. Well, I just know that you can sense what we all sense when you get back now. Incidentally, have you been able to follow some of the things that happened when you've gone? Did you know about the All-Star game?
Yes, sir. The capsule communicators have been giving us daily news reports.
Yeah. Were you American League or National League?
I'm a National League man.
Nonpartisan, sir.
Yeah, that's right. There's the politician in the group, right.
We're sorry you missed that game.
Yes. Well, oh, you knew that too? You really?
Yeah, we heard that...
yeah, the rain.
The rain.
Right.
Well, we haven't learned to control the weather yet, but that's something we can look forward to at tomorrow's challenge.
Right. Well, I can only summarize it because I don't want to hold you now. You have so much more to do. And, gee, you look great. You feel as good as you look.
Feel great. Feel just perfect, Mr. President.
Yeah. Are you, I understand Frank Borman says you're a little younger by reason of having going into space. Is that right? Do you feel that way, a little younger?
We're a lot younger than Frank Borman.
There he is over there. Come on over, Frank, so they can see you. And you going to take that lying down?
It looks like he has AIDS in the last couple of weeks.
Come on, Frank.
Mr. President, the one thing I wanted, you know, we have a poet in Mike Collins, and he really gave me a hard time for describing your words of fantastic and beautiful. And you were, I counted them, in 3 minutes up there, you used 4 fantastics and 2 beautifuls.
Well, just let me close off with this one thing. I was thinking, as you know, as you came down, and we knew it was a success, and it had only been 8 days, just a week, a long week, that this is the greatest week in the history of the world since the creation. Because as a result of what happened in this week, the world is bigger infinitely. And also, as I'm going to find on this trip around the world, and as Secretary Rogers will find as he covers the other countries in Asia, as a result of what you've done, the world's never been closer together before. And we just thank you for that. And I only hope that all of us in government, all of us in America, that as a result of what you've done, we can do our job a little better. We can reach for the stars just as you have reached so far from the stars. We don't want to hold you any longer. Anybody have a last word? How about promotions? Do you think we could arrange something?
Well, we're just pleased to be back and very honored that you were so kind as to come out here and welcome us back. And we look forward to getting out of this quarantine and talking without having glass between us.
And incidentally, the speeches that you have to make at this dinner can be very short. And if you want to say fantastic or beautiful, that's all right with us. Don't try to think of any new adjectives. They've all been said. And now I think, incidentally, that all of us the millions that are seeing us on television now, seeing you, would feel as I do that, in a sense, our prayers have been answered. And I think it would be very appropriate if Chaplain Pierto, the chaplain of this ship, were to offer a prayer of thanksgiving. And if he would step up now, Chaplain, thank you.
Let us pray. Lord God, our Heavenly Father, our minds are staggered and our spirits exultant with the magnitude and precision of this entire Apollo 11 mission. We have spent the past week in communal anxiety and hope as our astronauts sped through the glories and dangers of the heavens. As we try to understand and analyze the scope of this achievement for human life, our reason is overwhelmed with abounding gratitude and joy, even as we realize the increasing challenges of the future. This magnificent event illustrates anew what man can accomplish when purpose is firm and intent corporate. A man on the moon was promised in this decade, and though some were unconvinced, the reality is with us this morning in the persons of astronauts Armstrong, Aldrin, and Collins. We applaud their splendid exploits, and we pour out our thanksgiving for their safe return to us, to their families, to all mankind. Grant us peace, beginning in our own hearts, and a mind attuned with goodwill towards our neighbor. All this we pray as our thanksgiving rings out to thee, in the name of our Lord. Amen.
Amen.
Jules, there in the on the lower flight deck as the president went down to see the astronauts, I couldn't help but think that he reminded me very much of a very proud father who had gone to the hospital to see a newborn child and discovered that he had triplets. It was the most enthusiastic thing I've seen in some time from him.
He's discovered a new thing, Tom. He discovered it through Frank Borman, who has now become a close aide to the president, who was assigned to him for this entire mission. And he's discovered, I think, that in this torn, tormented time of ours, with a country that's searching for to do the things it has to do, that this great thing that's been done here, this lunar landing, is, if anything, a unifying factor. It's a moment of national triumph and dedication. And I think he really feels it deeply, as all of us do.
Jules, of course, one of the proudest places in the United States at the moment is the little Ohio town of Wapakoneta, population 7,000, and the home of Neil Armstrong, where Neil first began flying. And we have a picture from the home. This is not from Wapakoneta, Ohio. This is from the home of Neil Armstrong.
This looks like Jan Armstrong walking up now. Here's Jan Armstrong.
Representing the moon. Would you come forward, Mrs. Armstrong, please?
Yes.
How are you today?
I'm fine.
Have all your prayers been answered?
Yes. I would like to say to the President, to the Presidents of the United States, President Nixon, President Johnson, President Kennedy, to all of NASA, to all of the contractors that have helped to make this flight successful, to the astronaut crew, to the men, the 3 men who made this historic flight, and to all the peoples of the world, we thank you for everything, your prayers, your thoughts, just everything. And if anyone were to ask me how I could describe this flight, I can only say that it was absolutely out of this world.
Rudy, can you tell us how you...
So America has been to the moon and back safely and successfully. And we think perhaps in the process rediscovered itself and discovered that it can do anything it sets out to do. On the moon, to the planets, or in its own cities, in our own cities. Apollo 12 lies ahead in November, with a new landing site on the moon, Site 7, a new goal and new dangers as well as new rewards. And Apollo 13, 14, and 15 next year, as well as those cities, slums, and a people who can and will do all that has to be done when they know. The moon then can be seen for what it really is, for what it truly is. And we don't need to look through telescopes, only with our naked eye, to discover that the moon is nothing more than a mirror image of the Earth and what we can do ourselves when we set out to. This is Jules Bergman at ABC Space Headquarters. Tom?
Jules, of course, it was Presidents Eisenhower, Kennedy, Johnson, Nixon, all moved us along, supporting the space program, putting the power of the office behind the space program, continuing to keep it alive and vital with the necessary funds and the necessary full commitment. President Nixon there today was there as the chief executive, of course, but many other presidents, those I just mentioned, of course, have had a great deal to contribute toward this final goal of putting a man on the moon. But of course, the firm commitment was that of John Kennedy back in 1961 in an address to Congress when he said, we've got to be there by 1970, and we have.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish. But in a very real sense, it will not be one man going to the moon. If we make this judgment affirmatively, it will be an entire nation. For all of us must work to put him there.